today we are here. So we have the Energy Affairs General Director Associate would be here, but she is not here. He is not here. Uh, huh.
Sektörümüz şu an yıllardır bahsettiğimiz gibi tam bir hızlanma arifesinde. Burada tabii çeşitli zorluklar ve potansiyellerle geliyor ülkemiz. Kredi ve para piyasalarındaki dalgalanma ve kredi problemleri projeleri yavaşlatırken sektördeki motivasyon hala yüksek ve piyasamız gelir modelleri konusunda bilgilenmeye devam ediyor. Aynı zamanda Enerji Bakanlığı da gelir modelleri tarafında yeni modeller oluşturup batarya yatırımlarını hızlandırmak üzere çalışmalarına devam ediyor. Bu hepimize umut veriyor. Aynı zamanda derneğimiz üyesi olan birçok sanayicimiz Türkiye'deki yatırımlarına devam ediyor. Burada bizi umutlandıran en büyük noktalardan biri de hem Avrupa'da hem Türkiye'de enerji depolama sektöründe çok ciddi bir potansiyelin şu an aynı anda her yerde oluşmuş olması. Burada hem Çin'deki tedarikçiler hem Türkiye'deki tedarikçiler Avrupa'daki piyasalarda hizmet verebilmek adına bir mücadele içinde. Türkiye'mizde 35 gigawatt saate yakın potansiyeliyle aslında Avrupa'da önemli noktalardan biri olarak göz önünde duruyor. Bütün dünyanın aslında gözü şu an enerji depolama sektöründe. Bunun da temel nedeni yenilenebilir enerji kaynaklarının kullanımının artmasıyla piyasalardaki dengesizlik. Şu an Avrupa piyasalarında da çok net olarak gördüğümüz öğlen saatlerinde güneş enerjisinden kaynaklı sıfır fiyatların oluşması piyasalarda çok ciddi bir dengesizliğe neden oluyor. Bu dengesizliğin de aslında en kolay çözümü veya tek çözümü diyebiliriz. Enerjiyi depolamak ve bu gündüz üretilen fazla enerjiyi akşam saatlerine kaydırmak. Bu bildiğimiz bir sorun ama bu sorunun ne kadar büyük olduğu ve yenilenebilir enerji sistemlerinin kurulmasında ne kadar imkan sağladığı giderek daha rahat bir şekilde görünmeye başladı piyasalardaki durumlarla. Bu nedenle ticaret savaşlarının başladığı bu günlerde ülkemiz olarak çok büyük bir potansiyelimiz var. Hem yazılım servis alanlarında hem entegrasyon alanında hem de bu EPC tarafındaki inşaat ve işin gerçekleştirilmesi yönetimi konusunda tecrübelerimizi Avrupa, Afrika, Orta Asya, Orta Doğu gibi bölgelere yayma şansımız çok yüksek. Derneğimiz olarak da bunun zaten farkında olarak bu işe başlamamızla beraber şu an bu vizyonumuzun doğru olduğunu ispatlamış durumdayız. O yüzden ilk günkü motivasyonumuzla şu an çalışmalarımıza devam ediyoruz. Ve ülkemizde ürettiğimiz sistemleri yurt dışında temsil etmeye devam ediyoruz. Bu sayede de ülkemize çok ciddi anlamda döviz kazandırabileceğimizi düşünüyoruz. Bunun da meyvelerini almaya başladık. Herkese bu fuarın hayırlı olmasını diliyorum. Geldiğiniz için teşekkürler. Bugün boyunca bütün paydaşlarımızla beraber bu alanda
So we will share with you some information about this field, and thanks for your attention. Dear participants, welcome. Is kindly invited to the floor, and our speakers are Atalay Koyaş, Burak Özyol, Ömer Çiftçi, Ümit Bülbül. Now are only kindly invited to the floor for this session. Management of smart electrical network and innovative storage application areas. Welcome all. Can you hear me? Welcome. My name is Urjan Orhan. I'm working in Omega as the product and engineering director, and we are also in the energy storage sector. Now I want to introduce our guests, and now the theme of our session is the technological transformation in networks. We have Atalay Koyas with us, Burak Özyol, and Mr. Ömer Çiftçi, and Mr. Ümit Bülbül are with us. And there will be 3 different rounds of our panel. And in the first round, we will be talking about the smart network transformation. Our first question is to Mr. Atalay. Why the smart networks are compulsory, and what are the difficulties? And I'm the business development director in the guest area. And when we call about the smart network, from the classic network, passage from classic network to smart network is being realized, and the energy was transported in one way, in one direction. But since there are more renewable energy, and since we have more solar and wind power stations, now the networks started to work on dual direction grid connection. And in the before, only the production was made in the power stations, but now the production is being done everywhere. So for this reason, the grids must be much more foreseeable, and the unbalance in the network because of the wind and sol and and the solar power, they must be managed. And because of the infrastructure difficulties, so you need to apply these changes to the grids, and you need to make investments. And in Europe, these investments are being done, and in Turkey we are doing these investments in Turkey, and we need to collect more data from the grid, and we to analyze all the data from the grid instantly. And these are the difficulties, and we need to also foresee the imbalances that can occur in the grids. And why the storage is compulsory? Can you hear us? Do you hear us well? Okay. So if there's no problem with the sound, I can go on. As a matter of fact, why should we use these smart systems? Mr. Atalay made an introduction, but also the main problem issue in the grids is to manage the inequality between the demand and supply. If we cannot manage well this demand and supply, we can have some quality problems in the grid, and there can be some instant changes in the voltage, and this can cause some unwanted events in the consumption side, especially in the wind and solar energy systems. With the integration of these systems, this unbalance and inequality thing becomes more, because the solar wind and wind power plants are carbon neutral systems, but they have some disadvantages, and they are not, but this disadvantage is caused because of its intermittent nature. They can they are depending on wind or the daylight, and this causes some instant increases in the production, and they may not also respond to the demands. And for this reason, if you want to guarantee this demand and supply balance, we need to also guarantee the supply of energy, and we can only store this energy in this case. For this reason, the generation systems and the storage systems can be used for this. And for this reason, when there's a microgrid applications where the production and the generation and the consumption are occurring together, all must be applied at the same time, and this is the most basic solution for that. And for the microgrid application, in order to overcome this situation and to have the flexibility, we need to use the storage systems. Let's continue with Mr. Ömer. Mr. Ömer, now you mentioned about what are the changes caused by the digital systems on the field. Thanks. My name is, I'm coming from Solar Çiftçi, and I'm the sales director for Europe and Turkey. And digitalization and AI were somewhat supporting mechanisms 5 years ago, but today they are the main supporting factor for this production. There are billions of data is flowing from production to consumption, and this data must be used in a clean manner and is a very sensitive issue. And for this reason here, as everyone is witnessing, the cybersecurity is very important also. And now creating with it, together with the digitalization and with the use of AI, we have to also take into consideration some risks. Also in Turkey and in the near Europe, for the energy project, whatever the origin of the components are, the software must be local, and it must be under your control. It is very important. And for the digitalization, we are increasing the productivity of system. So, for example, it's very critical for the balance of demand and supply. I want to give you an example. For the solar power plant or wind power plant, we can see the past data of these power plants, and we can make estimations based on this previous data, and without human intervention we can do all these estimations, and we can make a comparison between the demand and supply, and this is what we are expecting from digitalization and AI. And of course, for the predictive maintenance, it is very important, the use of digitalization. The transformation of DC energy to AC until this access to the grid. In all these cases, if we have any abnormal data, the AI can predict all this, and without any breakdown, it can make some provisions, and this is very important for the operation of the systems. And the final question is to Ümit. The battery technologies what is the place of battery technologies of this within these grids? Hello, my name is Ümit Bülbül. I'm from the Sun Energy. I am the engineer from the engineering department. As Mr. Murat mentioned before, in the energy domain, whatever it's just like the heartbeat of the human being, and since for the renewable energy, with this variance is very intense, and this is not central, it is distributed systems, and for this reason the storage and the battery systems must be present. And when there's high capacity, the energy must be stored, and there is more need for the energy stored can be used. And for this reason, the battery technologies is an inevitable part of the grid in order to manage the grid in line with the international standards. And with the storage systems supported with the batteries at the endpoints, is enables to give high power output and gives more possibilities to the grid in order to feed more energy. And when there is a high capacity, you can use the battery, and when there is no need, the battery can be charged with the normal energy, and the cable transformers infrastructure can be much more easy, and the battery technologies, as a matter of fact, in the future, the future is energy is the storage, and for the sustainability of the services, these batteries are very important. And when there is a interruptions, the needed energy can be powered from the batteries. And if I mention again in summary, the grid must be stable, and the continuity of the energy feed and the storage is very critical function for all these issues. In the second leg, we want to mention more about the storage and the integration. We continue with Mr. Ömer. If the technology is enough, and what is the direction of the technology, Mr. Ömer, and it's a very wide issue, but what I see important here, the technology is never enough, is not sufficient for us, never. We want more in every different field. There will be much more developments, but today we have a energy storage sector which is highly commercialized, and people are so much interested in this field, and there's a very intense product development. And for the integration, also there is a very fast very fast development. Different manufacturers, different certifications are speeding up, and the communication protocols are now also being developed, and they have the ability to work smoothly now. In the next step, it may be a difficulty for us, but the battery systems, regarding the performance of these battery systems, the theoretical studies, of course, scientific tests, factory commissions tests are being done, but there will be other conditions with the other integrations. We can see other environmental problems that we did not see before. For example, in USA, a battery fire is being controlled, but within this time, these particles gets into atmosphere, and the environment is affected, and there's a pieces of ashes coming from this fire in the near neighborhoods, and the people over there are suing this company because of this fire, and they find out this kind of ash particles within their waters and their lands. And of course, also regarding the degradation, we can find maybe we will have 3 or 4 cycles of recharging, and there will be very fast degradations in these cases. So I see all these points that must be taken into consideration for the integration of the batteries to the grid. And let's continue with Mr. Murat. Mr. Murat, what will be the technical and economical barriers within this transformation? Yes, as a matter of fact, Mr. Ömer mentioned before a little bit, but I see that I will try to get into for a wider perspective. But what are we going to do with these battery systems, energy storage systems? There are so many things that we can do, but regarding when we think about the integration to the energy systems, we need to work on some certain points. And what can be these points when I think about it? There are some points that I want to share with you. First of all, So what is the purpose of utilization of the system? We all the time talk about the revenue model, but these revenue models can also be changed. Are we going to make a trade for this energy, or load shifting, peak shaving, or applications will be made that which are traditional, or are we going to have a microgrid systems and it will be independent from the grids? And what kind of revenue model are we going to have? So this revenue model can be to sell the energy, or it can be a revenue that can be obtained from also not selling this energy. Mr. Ömer mentioned about the degradation factors and cycle numbers must be very clear when we foresee these points. And based on these parameters, we need to define the system design life span. It can be 5 years, 7 years, 10 years, or 20 years. These systems can uh, continue for all these years. These systems based on design characteristics. Also, the storage is not a standalone system; is a sub element that can be integrated with other systems. We have the EMS software and also power electronics and also some voltage transformers and protection equipment can be considered, and there's the whole system in here, and the very perfect compliance of all this is very important. It's not about the dimension, it's not about the electricity, but also the communication is important. They must speak in the same language, and do they understand their comments reciprocally? We need to guarantee all these parameters. This is one of the difficulties, for example, for now. Also, based on the revenue model, would this system will operate autonomously or together with an operator? We started to speak about the AI or EMS systems. The learning, we can make the system an autonomous system with AI or the learning systems, or with the traditional approach, we can have different functions thanks to an operator. And we need to make this kind of decisions at the first stage. There are so many different teams. There are many things that we need to consider, but these are the things that I think that are very vital. And when after defining the priorities, our job becomes easier. And now then we have the supply side of the work. The companies can make this kind of integration, or the suppliers can make this kind of integration, and they can solve this integration problem together with the suppliers. But you need to first determine these problems, and these are critical questions. And when you don't answer to this question, we need to make some presumptions, and this kind of presumptions based on some criteria, as Mr. Ömer mentioned. With the change of the needs, we may go away from the predicted presumptions. And so what is the purpose of the system? And if we can define it in a very well, and if the legislations are also developed, and with the good legislation, I believe that we will solve these problems on the integration side. And thank you very much. Let's continue with Mr. Atalay. What will be the difficulties in the integration side? So I want to add some certain things. Well, one of the most important difficulties is the human resources, especially the young people in our country. They are not so much interested to the energy sector. We as a company, we are making so many job announcements, but the application numbers are low, and we have the difficulty in finding human resources. Why is it important? It's important for the integration. You need to develop the technology. You need to apply this technology in the field. So the electric engineers are very important. The software engineers important. So we need to solve this HR problem. Another question is about the regulation and financing problem. And regarding the regulation, so the regulation is being updated in line with the technology, but it is a little bit backwards, and both the investors and the suppliers, so they want to, they have difficulties to realize these investments in line with the regulations. So for this reason, we need to have updated and actual regulations as soon as possible. Another problem is the financing problems. The local and abroad investors, they have difficulties in to reach to the financing. As the financing is better, these investments can be performed much more faster. And another problem is the integration problem. And why this integration problem happens? You have a wind turbine and wind power plant, and the hybrid system, and you have the storage system. But here we have three different technologies: wind turbines, EV panels, and the storage units. And there are cells inside for the storage. There are different cooling systems, EMS, EMS systems, and all this must be integrated with the grid. As you optimize this system, you are becoming so much productive, and you can make much more progress to carbon neutral targets. And the difficulties that we foresee are like these difficulties as a sector. Mr. Umit, the final question comes to you. So, with what is the role of the local technologies for this transformation? So the reliability of the supply chain and the security of the supply is very important. We have, and we as the Sun Energy, besides our international cooperation, we are trying to find local solutions with national and local technological developments. And we have now new roadmaps for solutions for storage systems. And for the solutions, we have the first cylindrical factory in Europe and in Turkey, and we have different format cells. And besides them, when you put together the cells, so within the storages, there is the smart systems that we have designed, and also we have the thermal management systems, the reliability of the batteries, and we are doing also the designs and also the packaging designs and the regulations and standards application, and we have the test and certification activities. The battery is a critical element for the storage, but you have the power conversion systems and energy management systems are also present. And for security, there is the protection systems. And for this reason, of course, with the development of the semiconductor technologies, we will be much more productive and reliable systems. And besides that, in 2050 and 2053, carbon neutral targets are present for our country, and we have some studies for sustainability. And for example, we are producing batteries from waste material, and also we are working on reusability, and also we are in the UFUK program, which is a very comprehensive R&D program, and battery production from the used parts. And also, if I sum it up, from the battery design, electrical equipment, and energy storage systems, and all the solutions are the fields that we are working on, and we are trying to contribute to this ecosystem in this manner. Thank you. In the final leg, and we'll talk about the future and about the transform. We will talk about the transformation of the technology in the future.
Gereken başlıklar neler?
What are the key areas that we need to focus in the future? First of all, localization, manufacturing, technology locally. These are very important. About 30 years ago, maybe you all heard about this. Europe and the US have been the major hubs of technology development, but in the last 15 and 20 years, China has taken over leadership. And how did they do that? They first copied technology and then boosted the number of R&D staff and focusing on research and development. So they became a hub, particularly for renewable energy. And we can do the same thing. Maybe we need a collaboration between the public, private sectors and the universities. And there are some incentives by the government, maybe they can be multiplied. We need to develop and manufacture technology locally. So it's like we are always trying to catch up with technology, but if we do that, we can be the leader of technology. So in the future, localization will be one of the key areas. Secondly, big data and data analysis. Particularly the US and China have long been working on these technologies like facial recognition and storage of human voice. We call this big data. And now they are analyzing this big data. Now, the AI systems like ChatGPT have been created with the analysis of this big data. So we need to focus on that. And for energy storage, real-time monitoring of data and estimating future consumption can be achieved by using AI. The third key area is cybersecurity, because the more you use technology, the more cyber threats you are exposed to. You need to protect your network and your infrastructures. Thank you very much, Atulay and Burak. How can we speed up this transformation? That's a good question. We actually want to accelerate it, but before looking back at the past, I would like to share some numbers from the present, because they will show you why we need to speed up. These are numbers from February 2025. Turkey's total installed power is 117 megawatts. Wind and solar power plants covered 29% of this total installed power. So we are in a good position. But I would like to share some conflictual numbers as well. For the same month, when we look at the energy consumption and production, 28,858 megawatt hours of electricity was consumed in February. Renewable energy had only a share of 2.5%. So in the installed power, solar energy has 30%, but in consumption, we only cover 2.5%. Why? Because we do not produce this energy at the right time or consume it at the right time. So we cannot plan when we will manufacture this energy. We cannot intervene in the timing of the sunshine or wind. So we need to store the manufactured energy and use it when we need it. It's like the ants. We need to work like the ants. We need to have energy storage systems, because the solar energy has a small share in the consumption of energy as compared to the total share of solar energy in the installed power. We need financing, yes, and policies, but we need some technology development as well, because the cycle life of batteries is going up. Energy density is going up for energy storage systems. And there are some developments in power electronics. We can now achieve higher power, and the system efficiency is higher now 98.9, 99.1. These are the numbers that we see regularly in the energy efficiency. And smart systems are necessary, and the response time of the systems is accelerating as well. So these developments with the increased competency of system integration will help us build more efficient systems. Actually, the future developments can be summarized as follows. Thank you. Ömer, I would like to ask you a question on behalf of the industry. What is the most exciting technology for you in this industry? Every innovation is exciting for me, actually. Can you hear me now? In terms of the industry, the technological developments that I find exciting are particularly the battery technologies. But when we look at the most recent developments, 75% of lithium-ion batteries are manufactured in China, and most of the mines are based in Chile, Australia, and China. So it may not be too feasible to offer all battery storage systems to the world. And Trump is now implementing high tariffs against China. Maybe in the short term, that may affect the lithium-ion battery manufacturing in the U.S. And this U.S. has a huge accumulated knowledge pool in these technologies. It's the birthplace of batteries, actually. Maybe we will have new types of batteries in the future, like gravitational batteries, like pumping water from very big heights into reservoirs. So battery technologies may become more feasible in the US because the prices will inevitably go up. And there are some investments in lithium-ion batteries in Europe. We are negotiating with a partner in Italy. Sodium-ion batteries have 29% less efficiency, and the prices are higher, but its service life is longer and improvements are underway. I believe lithium-ion monopoly will be broken in the future, both by China and its investments and other countries. We will see some diversification, and I'm really excited to see how that will play out. Because battery technologies may come in various forms, not with ion or lithium ion or sodium ion. It can be stored in different formats as well. And with this battery systems, we will have a more decentralized system. In Brooklyn and in a neighborhood, the whole production is based on a system that runs on blockchain. So users sell energy to each other. Maybe it's too difficult to generalize that, but in that system, you don't have an intermediary. The producer and the consumer can trade energy via blockchain, and it's safer. It's more transparent as well. For example, here, energy swap and in blockchain may help facilitate this trade and build a faster system where we don't have any intermediaries. Thank you. Last question of this round, Ümit Bey. What are your expectations in the battery technologies in the middle run? In the future, I believe the renewables will have a larger share in the energy mix. Maybe the installed power may be different, but the amount of renewable energy may be smaller, and you will have to store them. And there will be a higher demand for storage systems inevitably. So the capacity per unit is very important here because the capacity can be increased per cell and you can use fewer cells and fewer contact points and have more compact design. And the cycle life is very important because it determines the cost efficiency of your project. And security is also very important. The security of the battery system that you use is very important. And it should be financially feasible as well. So capacity, cycle life, costs. I believe these are the new criteria for the new technologies. And lithium-ion and lithium phosphate iron technologies are available for new batteries. Both systems help increase the capacity and allow for more improvements on the battery technologies. And out of service battery material can be recycled to contribute to the circular economy. There are some regulations that are being put in place to ensure that. So there will be some recipes to recycle electronics and battery materials in the future. People are discussing them. We are talking about energy storage, but these are smart electronics, so you need to have power regulation and power density components at the inlets and outlets of these systems. There are some compact and high efficiency systems and power electronics will be combined with energy storage systems to give us more efficient systems. And monitoring. Now the wastes can be monitored to the level of cells. And we have an international project to monitor the waste coming out of these cells. We can monitor the materials used in the cells, the tests that were performed on these cells, so we can follow the whole history of the cell and create a passport for these solar cells. And I think these systems will be further developed in the future. And now it's time for the closing question. What will be the most important component in the most important factor in the future in energy efficiency? I think certificate of origin will be very important. The trade wars are increasing in the world, and I think local production will be very important for the US, for Europe, and for Turkey. What do you think? I agree with you, and I would like to add that humans and environment will be key. There are various regulations to fight against the climate change and to achieve the carbon neutral objectives and to reduce the share of conventional energy sources in the energy mix and push the share of renewables in this mix. And in line with the carbon neutral objectives, we need to build more efficient systems. We need to create less CO2 emissions, and we need to optimize these systems so that we can use less resources, and of course humans lie at the heart of everything basically. Murat, what do you think? Well, of course I agree with what you said, but I would like to add a few notes. In energy, we need to reduce our dependency on other countries. So instead of conventional technologies, we need to put the renewables at the heart of total energy mix. That will help us improve our leverage in terms of dependency on other countries. Of course, the electronics, the technology, the equipment, the panels, or the wind turbines, the manufacturing of these components is very important. And we have an industry that has high CO2 emissions. With the latest CO2 regulations in Europe, the industrialists will have to keep the CO2 emissions under a specific level. This is where energy transformation becomes very important, particularly in heavy industry. Energy input is one of the major costs. So we need to identify efficient energy resources that will help us minimize the CO2 emissions. I agree with you. As I mentioned earlier, the supply chain is very important. International collaboration is very important, but for reducing the dependency on other countries, local production and design is very important. And sustainability and reuse of waste for circular economy, these are the highlights of the future. Another critical issue is the energy storage systems. They are becoming more popular in Turkey. But it's important to have some tests and certificates for these batteries. Batteries have to be safe and secure. So the international certifications will be more important in the future. This is all I have to say. Thank you. Ömer Bey, what do you think about this? My vote goes to software. The software in energy management systems should work efficiently, and cybersecurity will be paramount. Cybersecurity will be the second most important factor. Thank you. We would like to thank you very much for your attention. It was a great session, and we would like to thank the panelists for sparing their time to join us. See you. Thank you.
Soru cevap belki bir 5 dakika ayırabiliriz.
Maybe we can have a 5-minute Q&A. No questions? Okay. particularly for the renewable energies, we need batteries to store the energy. In the past, we had lead batteries, but now we have other technologies. And also for the EVs, we need batteries. And in terms of electricity, we need to reduce our environmental impact to become carbon neutral. But after becoming a waste, these batteries have a significant impact on the environment, and we need to manage that impact. We are going to discuss that today. We have a good panel. We have experts from the industry. Thank you very much. If you like, we can directly start with our panel. Question 1, Mohammed Bey. In recent years, the battery production in Turkey has been accelerated. Do you think this growth is a risk or opportunity for Turkey?
Now, hello everyone again. So apparently, this issue is not only about the energy storage, but it's about the EVs, consumer electronics, also about the energy storage in the final years, and for for the pack production and the system production, there's an acceleration, and this is a good thing. And this, at the same time, is has an interest of Turkey in an indirect manner, and it will have a positive impact of the companies working in this field in Turkey, but the partners in this supply chain and the, the after post use of these batteries, there will be very good opportunities, and this is regarding the environmental issues. This will have a positive impact on Turkish companies. But we need to also consider this. These batteries, of course, especially regarding the energy storage, it's a green energy, is the promise. But of course, together with the renewable energy, they can be employed, and this is a good thing. But also during the production, these batteries, both for for the production of cells and of the systems, they must be also fed through renewable energy. For example, these factories must be supplied with solar energy or with other renewable energy sources. As a matter of fact, from one side, we can talk about the green technology, but also we need to also use the green energy for producing that technology. And another issue is the local effect of this acceleration and this local impact. So for this productions, for example, we need treatment systems and organized industrial areas. They are acting in a organized manner more, but especially for battery manufacturing companies, they must I think they must have a special regulation. And also this, if we need to have a much more positive effect on the environment, we have to go we need to have much more cobalt and lithium ion. For nickel and cobalt, we should abstain from this because cobalt has if we have a cobalt free technology, there's a 15 or 16% more less emission, even though it's a primary technology. Another issue I want to say that, of course, we want to be a regional base for battery, and I think Turkey has this kind of potential, but at the same time, for the same reasons, because of the closeness to Europe and Middle East, but we can be a center for recycling, and this trans effect is a big challenge for this, and so we can be a recycling hub, and we can have this kind of role. This is what I think. Of course, nickel and cobalt are carcinogenic products, but there's nickel and cobalt, and for the employees will be subjected to these products for during the recycling. But so of course we'll talk about the recycling, and top association is working on this, and so and I want to give some word to Nissan Voyage'lar. What do you think about this recycling rates? I want to mention first about our association, and we have been established based on legislation, ministerial legislation, and so the companies had to collect some part of the batteries produced by them, and they cannot do it alone. And for this reason, we have decided to make it under the umbrella of the association, and the Ministry of Environment. Since 2011, we are working on this. We are we are we are a unique association, and it's a waste that has a negative economy, and we are spending money for this. But we are the sole association doing that, and we have a 21 years of past, and we are working on training and we are trying to create awareness, and in each field we have products that are operating with the batteries, and within the trainings we are we are trying to minimize the misuses of these products. For example, we tell them to keep the battery away from the extreme heat, and also we are also creating awareness about the recycling of this product based on environmental rules, and our biggest supporters are children, and so and they are a generation which learns this kind of environmental consciousness is a very important issue. So they will have this kind of awareness for the future, and this can be a battery or other wastes. They will collect more, and there will be more collection of this kind of wastes in the future. And within the final 13 or 14 years, we are realizing these campaigns in the schools, and these PET batteries, the 40 or 50% of these batteries, waste batteries, are coming from the schools. Of course, we have hotels and youth centers, and also we are working together with the detention centers, and we are working together with them for the collection of these batteries. These batteries are recycled, but we have a lacking sites. We have disadvantages because the waste collected cannot be is not enough for this kind of facilities. It's around 750 tons per year, and this cannot cover the operational cost of this kind of facility. And the battery is creating a negative economy, and we pay for the recycling. And if the waste quantity increases, this can be a positive economy, and this can cover the operational expenses. But what is important is to increase the awareness. We have a Exicon company. They have a facility that is working on this actively. Another company took a license from the ministry, and we don't work with them actively. But as Mr. Mohammed indicated, in future, of course, we can be a center for the recycling. Of course, European directive has some restrictions because they have some ratios for the use of these products coming out of recycling into production. And for this reason, in reality, this cannot be applied maybe, but if that happens, uh, this can be an advantageous situation for also for our country. Thanks, Miss Neslihan. Another question is for Shukran, Mr. Shukran. Aspilsan for years very intensively worked on the defense industry. In Kayseri, they started to also work on power sector. But the better is, of course, you are working with the industries for the defense industry. And but what about the sustainability? How do you ensure that? And what is the biggest challenge for you for environmental issue? For example, collecting these products, etc., etc. What are the difficulties? Hello, everyone. Also, we would like to thank to our moderator and the panelists and Sun Energy, Şükran Uzuncuk, and the sustainability manager. Sun Energy serves to the civil sector and the defense industry. And even though, of course, sustainability is an inseparable part of our strategy, and we are also giving a direction for the civil sector besides the defense industry and the circular economy and integration of circular economy to our production processes are critical priorities for us. Of course, we have environmental challenges, and because of our production difficulties, we have also very important quantities of consumption of water and energy. Also, we are depending to foreign countries for critical raw materials, and of course their global influence to environment are also assessed of these raw materials coming from abroad. For this reason, we give importance to have local products. Also, recycling is a priority for us. This environmental sustainability, of course, is not a challenge for us, but we think as a trigger for the transformation. As Ms. Neslihan indicated about the role of children regarding to environmental sustainability is not about the innovation within our organization, but for since 2 years, together with the Kayseri National Education Directorate, we are giving uh, trainings in high schools for 2 hours, myself and my friends, and the climate change and the sustainability information and details are given to the students in high schools by us. And for environmental challenges, of course, as I mentioned before, the our dependency to foreign countries for critical raw materials is very important. But for systemic challenges, from one side, the costs for this transformation process, even they are not deterrent for us. It causes for us to go slow, and another unmatured ecosystem. The recyclers, of course, all these regulations, in order to go, all of them go all together. All the system, we are trying to have connections on one-on-one with all of them, and these unmatured regulations are also slowing us down. And both with our associations, with our ministries, or regarding together with our councils, we are working together with them, and in order to create a sound ecosystem, we have difficulties, challenges. The EU regulations and we know that the EU regulation will be published, the Turkish local regulation, and there are very challenging conditions and clauses within these regulations. And for batteries, we have some challenges in use of recycled content, repairability, traceability are challenging situations for us. But we at ASP Sun Energy, we are working on the infrastructure of all this, and I can enlist all of this like this. Thank you, Ms. Shukran. Now, we mentioned about the situation a little bit, but minimum recycle efficiency is mentioned by Ms. Shukran. We will have the new EU regulation, also have the local regulation. We need to also check the regulations, and I want to start with the Ms. Neslihan. The top association is working together with the Ministry of Environment, but the manufacturer responsibility is so much emphasized in EU. But so what kind of preparations is being made regarding this recycling and responsibility, manufacturer's responsibility? And our own legislation is so old. It was issued in 2004, and it was in line with the EU the directive. It was based the EU directive of 91. Then, but afterwards, this directive has been revised by the EU. But we have a 40 years old legislation. So there are different stakeholders in these regulations: the local administrations, the sellers, the markets. But there are no targets, because these targets given to the manufacturers are so high, and the targets in 2010 for nickel cadmium is 84%, and for the batteries is 40%. But there are some realities of our country, but those targets are so high, even they are not even valid in EU. So this is a situation that we must we take into consideration. For this reason, our legislation must be updated as soon as possible. As also Ms. Shukran indicated, there are some studies on this, and with the EVs now, this works on this kind of approach has been speeding up, and for this reason, when we look to the manufacturers' liabilities and responsibilities, there are some controversies, and so there's the systems, and so for the batteries and accumulators, you need to reach to the manufacturers, and so 99% of course of them are important, and environmental compliance is certificate is required for the import activity, and you need to have a waste management plan. And they also talk about how to recycle, and how to dispose all these products, and the companies are becoming a part of this. Our association is because of this. They are becoming of our management plan. Of course, the responsibility belongs to the companies. The association cannot be left alone, but the companies must be included into system by themselves or by their dealers. We are also working for them, but points that we can reach, our speed is variable. So, of course, the ministry all the time must controls the responsibilities of the companies. But I don't think there are no disadvantages for becoming inside the system, and these controls are being done during the import procedures. And in 2021, the the cycling contribution payment, and so there's another burden on the product produce, another financial burden on the manufacturers, and the also we have the GECAP is also collected, and the sector has problems. The manufacturers, the importers, all of them are paying, and this creates an imbalance in the markets. So we have different challenges. Even though we comply with other challenges, we have new challenges, and for this reason, we need to act very fast in order to overcome this kind of dual payment. Of course, the control and audits are very important for the collection of the wastes, and of course, over there can be more audits, but the waste battery collection supervision is very low, and zero waste regulation brought us many advantages. But of course, if somebody gets a box from me and places it in their store, and they don't control if there are batteries are collected or not. So I think that we need to collect more. And I will make a question to Mr. Mohammed as the producer. So our environmental regulations are giving more direction. Do we have right incentive policies? Are there deficiency in this area? Thank you. And very openly on the battery side, the incentive mechanism of the government is somewhat okay. For investment incentives, calls, and HIT 30 program announced this year, we are somewhat good in this area. This can be better, yes, of course, but we are good. But what is important in here for these incentives, in none of them, the environmental impact of the battery is not mentioned within these articles of these regulations. There's no nothing, and there are some incentive programs, so the green support and 18 to 32 program of TÜBİTAK, and we are thinking to also apply to this program, but I think this will not be sufficient. Also, there's regulation side in this area. Of course, the battery passport issue is the factor that will have the most impact. EA is a little bit more in front of us, but also I can say that we are at a matter of fact behind. And the Trade Ministry made a blog page last year, but this was not sufficient. And this battery passport must be clarified as soon as possible within the regulations. Another issue is that the thing that I want to indicate is the second life issue. So the second life, the battery second life, according to me, Turkey must work on this and should not miss NNC type or NCA type batteries for the user consumer electronics or the EV. For in the EU, the health status of the battery, I want to tell it for the people that may not be knowledgeable about that. When the health of the battery is below 80%, the recycling stage can be started, and the guarantees are generally given like this. For energy storage, since there is a more competition and there is a need for more investment, and this went down to 65-75% with the competition, since it's because the lithium iron phosphate based. But so at this stage, it is not good to start the recycling at the final cycle of this battery, because this battery still breathes, and 80 or 65% of the lifespan of this battery still stays on. It's not a linear life, but it will have an exponential life, but it may continue to live for 5 or 6 years in different applications. For residential applications, it can be used in a residential application, and EV battery with a very low prices can be placed in a garden of a house, and it can be a battery for charging an EV, for example. There must be some incentives for that as soon as possible, and I think that it will be very important if there are some incentives for that. And you need a very important supply chain, and of course, together with the BMC, those companies, as a matter of fact, defining the age of the battery is not an easy thing. And for this reason, so starting from the birth of that battery, and so someone who takes care of that battery all the time, and then who calculates, we need to have a tool that can calculate all the lifespan of this battery. This is a battery management system, and this is a battery also passport is needed for that. And this issue is very attractive. And Turkey, in my previous talk, as I mentioned over there, regarding the supply, Turkey can be a hub for this. And our friends also mentioned until 50 or 70% recycling target must be present. All these objectives, not for the manufacturers, the investors must work on that. The manufacturers, recyclers, all of them must deal with that. Also, our friends, they are working on this. Also, education is very important. The public also must ask for this, and for this reason, it is very important. But with a, if I want to say one single sentence, regulations and incentives are influential up to a certain point, or personal or corporate responsibility is up to a certain point, but there must be a commercial logic for that. When the second life, for example, is very important for the commercialization process, and so it can create a commercial this can create a commercial logic for this, and this can be influential for our region and for our country. And here the manufacturer responsibility, recycling company must not be considered as a person that as a refuse collector or a scrap dealer, but what the manufacturer tells about that. For example, who will be responsible about this second life, or generally on your site, the the producer works on innovation. Sun also works on that. And what is your comment on that? So, as a battery producer, we have an expanded reliability for manufacturing, and at this point, the EV batteries with their second lives, all these processes are a little bit are not so much determined, and the battery and the battery belongs to the manufacturer or to the owner or to the manufacturer of the car, who is the owner of the battery. Type association now is managing all these processes and recycling and of the this disposal of our batteries are sent to top facilities. And regarding the responsibility of the second type,
So, do you have the mandate, or do the manufacturers have that mandate? Yes, the manufacturers can actually take over that mandate. But to be honest, our priority to have a well-established ecosystem, because we have a lot of inputs here. In the battery passport systems, there are a lot of inputs. So the recycler, the manufacturer, and the end user have diverse inputs in the whole process, and we still don't know what these inputs are. So we have the Horizon project, and as a manufacturer, we list our inputs in that system. But in Europe, there are systems in place, but those systems also have some gaps. And before having a legislation, we need to have a solid foundation. Otherwise, there may be a disadvantage. A lot of misinformation, inefficient practices may arise. And instead of becoming more efficient, people may get tired of dealing with these inputs. So we need to take the right steps in that direction, because sometimes you may have difficulty in finding competent staff to manage the process, and manufacturers may get confused about what to do in using those systems. So we need to move carefully. So we talked about how data is important because the world is digitalizing, and you already mentioned this. I have this question for you. When you have a digital platform that will monitor everything, how will the collection process be affected? What are your recommendations to have a proper system? Who should be the collaborators of this system? And will this platform be built by the government or the private sector? Or your association, will it create its own platform? Because you creating a platform to collect all monitoring data may be critical. Actually, we have a monitoring platform, but since we don't have a mandate, we keep that data in-house. We use it for analysis in our own organization. But to put it more clearly, we need to identify who will do what the consumers will do, the manufacturers or the chain markets or the hotels. Their responsibilities and roles should be clearly defined, because when you look at other types of waste, battery is overlooked. And it has always been this way. I have been working in this association for 19 years. I see that when you talk about recycling, people talk about plastics or paper. They don't think about batteries. And they say we are recycling. But in the background, you have to deal with tires and mineral oils and batteries as well, in addition to paper and plastic. And they should be dealt with equally. And I think the legislation should do that, because one of our responsibilities is to publish public announcement films on TVs. Of course, we shoot these videos and broadcast them, but if you broadcast them at 2 a.m. in the morning, it doesn't make sense. So we need to have prime time hours. We need to have some screen time at the prime time hours for these films so that people can know about their responsibilities. Because people should not just look at environmental impact in terms of monetary value. We have this climate crisis and the climate change, and it should be understood in that context. After we establish everyone's roles and responsibilities, it's the easiest thing to create that platform. We have an automation system, and we follow the number of batteries recycled by each organization. And we also have some application forms for those who would like to request a battery collection box. And even if you Google what to do with the used batteries, that form will come up in the search results, and you can access it easily. The local governments or the delivery companies will help us pick up those boxes when they are full. But though, to do that, we first need to create awareness so that people can understand how they can use the boxes. So we have created our own platform. You can check it out. The policymakers can also check our platform. But we first need to identify the roles and responsibilities in the system of battery collection. And I would like to give a few examples. We are also a member of some battery collection organizations in the European Union. In the European countries, 35% of the batteries are collected at chain markets. That percentage is only 2 in our country. We tried everything, but it still stands at 2%. Maybe we can do some audits or set some objectives for them, or assign them some responsibilities for the number of batteries they need to collect. It would be more effective. We can do the same thing for the municipalities. We can see 2 municipalities that are neighbors to each other. One is collecting 10,000 tons of batteries. The other one is collecting only 2 tons. So there's a problem there. So it always boils down to the question of auditing. And we are starting the final round of questions. Unfortunately, I have this impression about our country. Neslihan Hanım also knows this. People are asking whether Turkey will become the waste center of the world. And the European Union is restricting exports of waste battery. What should we do in that area? What kind of awareness we need to raise with the public? And after your answer, we will get very short answers from every participant to the question what we should do to have a more efficient battery collection system. Well, it also relates to what I said earlier, the question of second life. Because we need to tell to the people that this is something that we can commercialize. If businesses can have a better understanding of the potential here, we would have less challenges and it would be easier to take some action. And I would like to say one more thing about this. On the R&D side, we are launching a project very soon, a project focused on Second Life. Because we said you need to have a BMS. Otherwise, you cannot do it. Because when you bring the batteries to a recycling center, you don't know the age of that material without using a BMS. So for many years, batteries have been manufactured. Some of these batteries do not have BMS. Or some used to have BMS, but they don't have anymore. Yes, battery passports will be here in a few years, but the batteries that will be manufactured by then will not have a passport. In this R&D project, we are monitoring the battery at the cell level. And this device can estimate the age of the battery. Because when we can do that, you can have more alternatives for a battery. Because if they are not the same age, you cannot build a new battery by recycling them. They need to be approximately the same age so that you can use them in the same package. And that may create new facilities that we call remanufacturing facilities. And all cells that can be remanufactured do not have to end up in Second Life. Some of them may not be okay, and they may be directly sent for recycling. But we should not just jump to the final link in the recycling chain for every battery. So if other companies would like to collaborate with us in this R&D project, we would be more than happy to welcome them, because we believe in open innovation. And manufacturers can wear two hats in this process. They can be a supplier of these remanufactured batteries and or storage. Energy storage companies can be a supplier of these batteries. As I mentioned earlier, in a residential application, energy storage company can sell these remanufactured batteries that are created for a second life. So I believe this is a very important topic. Secondly, particularly in utility skills, sodium ion looks like a more eco-friendly technology as compared to the technologies we currently have, and we are also working on that technology. So this is an important issue where we need to collaborate. The associations and the companies should collaborate, and they should collaborate under the spirit of open innovation, and we are ready to do that. Thank you. Okay, let me continue. I would like to thank you in my closing remarks, and I think to minimize the environmental impact of batteries, the most important thing is the recycling and disposal of these batteries. Of course, localization and reduction of carbon footprint in the manufacturing processes, efficiency at the source, and energy efficiency are very important. And when one industry starts implementing these measures, others will replicate that, and it will become inevitable. However, battery means mobility of energy, and it's a perfect innovation. But in terms of process, it has a huge impact on the environment when it contaminates the soil, the air, or the water. So collection and disposal of batteries are very important, and Nestle already mentioned this. We are not talking enough about collection because we all use batteries. Everyone around us is using batteries, but they don't have the awareness. They don't have the awareness about how energy comes out of the battery, what happens to that energy, and what happens to the battery when all that energy is used up. I think we need to pay attention to that as well. Localization is also very important. In recent years, we had a project with Eti Maden focused on producing NMC from mine waste. But on the other side, one thing is overlooked, and that is environmental impact. I don't think that is emphasized strongly enough, and I hope it will be more in our focus in the future. And Shukran and Mohammed already summarized it very well, but you may think this is the ad break, but I believe it's important to reach out to as many people as possible. So if you have never collected batteries so far and start thinking about battery collection after joining this session, I feel very proud. Thank you. And I would like to thank you very much as well. Have a nice day.
Doğacan Bayram, Hakan Öztürk, Hatice Elif Bayezid are also invited to the floor for this session, which is organized by EDEDER. Dear participants, welcome. First of all, so can you hear me well? As you know, our topic is the regulation and the relative proposals, and so I want to give some brief information about the year 2000. So I want to tell about some legislation, and I will also talk with our guests. In 2001, so it starts with the electric market law, and in 2005 we have the renewable energy law, and it continues with that law in 2005. And in 2011, the unlicensed electric regulation started with YEKDEM. Also, we will mention about this in our session. And many different energy actors, they know. We have a 2646 law became active, and also in 2018 the site services regulations. In 2019 with the new electrical manufacturing without license has been put into force. But for energy storage we have some milestones. We have in 2001 the storage term started to be used in the legislation, and after its application in year 2022 the integrated production storage systems, they started. At this point many applicants, more than 33 gigawatts project stock, and then the processes of the job they continue, and the chat processes, and together with the wind and sun until 7 gigawatts we have a storage system. And also after this kind of start, so I want to introduce one by one the speakers. Mr. Hakan, you can introduce yourself. Thanks a lot, Mr. Erhan. My name is Hakan Öztürk. I'm coming from the Pomera Energy Storage System. I'm the domestic sales director. Thanks for your participation, and I hope that it will be a fruitful presentation. I'm coming from Enerjisa, and my name is Hatice Elif Bayezid Çelik. Hello, my name is Doğacan Bayram. I'm from Innovators Energy. I'm one of the managing partners of the company. So with your permissions, I want to give first word to Miss Elif. So it's regarding YEKDEM. As you know, many investors are waiting for revenue from YEKDEM. But regarding the YEKDEM mechanism, there are some uncertainties about storage, and I would like to know your proposals, your thoughts, and So for the feasibility study for power stations with storage, the YEKDEM is very important. This uncertainty in YEKDEM also creates an uncertainty to side of the investors on the side at the moment of making decisions. And there are two different explanations on that. As a matter of fact, if we look to the energy market regulations and the YEKDEM regulation for the storage, so with the tariffs is the price of 243 Turkish liras in March, but with the decision decision of the President of the Republic, the price is lower, and in the free market, together with other transactions, so you can do arbitrage for PPDK. It shouldn't the power stations should not be within the coverage of YEKDEM, because for YEKDEM is an important issue for companies because it's the guaranteed income, and so the price issue is very important, and is one of the resources that may influence positively the investment studies. Of course, there are some certainties. For example, for the gas prices from the solar production for the peak shaving, there's the peak shaving scenario, and the price over there is 246, is 18% more price, and this creates less effect on feasibility, and peak shaving is a restricted area. For this reason, this price must be applied in all power plants with storage, and this will influence positively the investment decisions. I want to make a question to Mr. Hakan for YEKDEM, the local equipment requirements. So what are your general comments? If you can make some comments on the storage issue and the local manufacturing. Thanks a lot for investment side. So for the investment argument, for instance, regarding the economic revenue, is another positive issue that may create some revenue, is the revenues coming from local equipment production. In May 2023, regarding the local equipment, there has been a draft of legislation, and so 50% of battery and bidirectional inverter by 30% to BTS equipment, and BMS and EMS by 10%. So can be an argument for the revenue on the local components. Of course, we are including this for the feasibility, but for 23 issue is still a draft. And for local production, this equipment, these components can be an argument for more revenue. Yes, it is important because of the contribution of domestic production and batteries that may be imported from abroad, the additional custom duties, and causes an increase for investments cost. The local components must be included into the legislation as soon as possible, and this will create a positive effect for investors. If you look to the local producers, so the accepted 30% section, we will be able to supply the 70% of the components. There are some producers that can do that. And this, if we add this as a contribution, and if we look to the amortization models, this creates a very important contribution. And if we speak about our recommendations, and so this local components issue must be included into legislations. This is our suggestion, and thanks a lot. And another question to Mr. Doğacan. As you know, within Turkey, because of the formation in Turkey, the energy storage is based on grid dimensions. So we wish that there could be a TNI projects or pilot projects, but so 5-1R. So without sending energy to the grid, the usage without sending energy to the grid, how this can be done technically? This is can help to many projects because of the capacity issue. This can help to this kind of projects. What do you think? Thank you. 5-1C is an interesting thing for everyone. As you know, it's except the wind, but for the solar panel producers, the sun, so there are some companies that wants to install the solar panels for their own consumption. EVP companies, EMS developing companies, SCADA companies, for SCADA companies, which is very important because within the Turkish grid, so the fact that we are not able to install more solar energy in Turkish grid is because of the intensity in lines and transformers, and also so in case of more solar installation, there is an excess production on the day, and this is restricted. And TEH 14 billion Turkish lira must reserve a budget of more than 14 billions of Turkish liras. And the grid operator is right also here, because the making this kind of balancing is not so easy. We are inside a pool, we are together with the Europe, and within this pool, this instant production and consumption must be equal, and this is done by planning. And for this reason, the storage systems are very important. But of course, because of the intensity of the transformers, we are talking about the consumption at the place of production, and this requires a little bit more smart network, smart grids, and you need a storage system. If you don't need the energy while from your solar panels, you send it to the grid or you lower down them. But this kind of 5.1G, they say that for a producer for their own consumption, if they make this, they can reduce their consumption if they have a production. But with the condition of not feeding their excess production, they must be able to install these systems without giving this kind of undertaking. But TEH thinks that even though you make zero at the moment of the solar production, this creates an imbalance. We have an excess production and you are lowering the production. They are somewhat right, but abroad they do it like this. They solve it like this. They have a fine for storage systems. There are some peaks values, and it is called zero injection. It is completely prohibited to send this energy to the grid. Maybe the consumption level goes down within the day, but it is much more balanced manner. it can be distributed to the normal curve, and here must be the market price motivation. So in order to let people to store this energy when it is cheaper and sell it when it is more expensive. So this must be planned. When this is done, many industrials, they will want to lower their energy costs, and there must be certain regulations. But the Ministry of Energy, they have a serious motivation on that. They work on that, and we think that this will have a positive outcome. And this is connected like this. So we have for the demand side management, the EPDK thinks about that, and also there's a collectors area. So place the production, storage, and consumption at the same point. 5.1c is being supported by these structures. I think in the next 1 year, then I think that there will be a new investment item, according to me. Thanks a lot. Now I want to make a question to Ms. Elif. What are the revenue items of energy storage? So to doing energy arbitrage is very important. We are talking about that intensively. The PTF prices, the base prices, and the maximum price, ceiling prices. And in Turkey, we started to see the zero Turkish lira prices in Turkey. Can you give us some examples of that also from abroad in order to have some changes in the legislation in order to increase the arbitrage operations? Of course, I can. So, but this power plants with storage systems, in which conditions they can do arbitrage? I want to talk about that. They can freely trade this energy in this kind of scenario. They can make the arbitrage if they do this kind of trading, and they can have a revenue item like this. And so we have some maximum and minimum price application for market prices in our country, and the maximum is 3,400 Turkish liras, and it can be minimum 0 Turkish liras, and there can be no minus prices. But why this is important in arbitrage? For example, from what was the price of storage and the cost of storage of this, and also you have a energy that you lose from charging and discharging, and can you make money because of this cost? So when you charge it, the price must be low, and when you sell it, the price must be higher. So for this reason, together with April, there has been an increase of 13% on the base price, 13% on base price. Last year in Germany, there has been a negative price by 457 hours, and it used to be 358 in the year before. So when the price is negative, you can store, and if you make the sales when there is the high demand, it can optimize the prices, and it can contribute to the battery optimization. Thanks a lot. Now, I want to make a question to Mr. Hakan. Some months ago, there has been some regulations from TEH. The storage has been defined a little bit more with this regulation from TEH. And regarding the capacity of the batteries, there has been a standard of the reduction of the capacities of the batteries. For example, within 5 years, it can be 15% of loss of capacity of the batteries. And regarding this issue, regarding its predictability, and when this degradation ratio is higher, the energy of the central, so to supply this to Yekten free of charge, is there a legal infrastructure for supplying to Yekten free of charge? What can you say about that? When we look to the storage site regulations until the final month of 2024, it was going very slow. But as of 2024, at the end of the last week of December, and for the acceptance of 2025, the because of the degradation in battery capacity, there have been some regulations that put into force. In the first 5 years, I can accept a 15% of loss, and for the subsequent years, a loss of 20% can be accepted. And after this regulation, for the acceptance of the storage and resource acceptance during these tests, the ministry accepts a 10% of tolerance. For example, you have 100 units of storage, and for the first acceptance, 90 units of energy can be charged or discharged during the acceptance tests, and this can be acceptable by the ministry. And of course, there's another source, there's an auxiliary source. The manufacturing energy is stored, and with different scenarios, frequency control, and with the arrangement of tension level in the grids, there can be more support. And the batteries at this point, as I mentioned before, as they have been used, as it happens in all components, they are degrading. And with the lithium batteries from anode and cathode area, we have a separator. As the transfer of the lithium ion, there is a potential difference that is happening. But these ions of lithium, after a certain time of transfer, with the wearing of the components in between, and there can be different scenarios. And on the battery side, so in 19th of November 2022, this has been put into application, but this is because of the balance thing on the grid, in order to correct the imbalances in the grid. And if we think about 6,000 cycles, if you think about the long-term investment, of course it must be taken under control. And regarding the technology, if we look at the manufacturer on the technology side, if it is used, the state of health goes down. And so as a result of the analysis that we did on the battery side, it happens in the solar panels. In the first year, there's so much degradation in the first year. In subsequent years, they have a stable degradation. And within these losses, it is not only the wearing of the battery, but it's not only the energy losses, but of course the general productivity of the system and other equipment, the PCS and transformer and cable losses must be taken into consideration. And as a result of the calculations and the tests that we did in the first 5 years, regarding the 15% of capacity and for the 20% capacity in the future years with a certain coefficient. So let's say for solar, for example, we can have a higher DC capacity and we can get the right AC capacity. We have to do a scale up also on the side. Of course, when this can increase the first initial investment amount for the investor, but since the ministry gives the 10% of tolerance, can also help to the investor on the side of the costs. Since also we are also investors, we are also doing calculations from based on this side. And the first year 15% and 20% of better life until its end of life. Within all this time span, these ratios can be applied. And so regarding the meetings that we did with the ministry and we as the association, also we mentioned about these figures, and these ratios can be, the ratios are reasonable ratios as far as I think. Thank you, Mr. Hakan. Now I want to continue with Mr. Doğacan. So regarding the revenue models, there are uncertainty about them. Regarding the reference, making reference, so I want to indicate, I want you to speak about the revenue items that may come from the batteries, and so and I want you to talk about the reactive and the fast reference systems of batteries that is being used in Europe. So can you, if you can tell something about them, I would be very glad.
Arbitrage is the first thing that comes to the mind because we already know the market prices and we know the bid prices, and we can sell, we can buy energy at cheap hours and sell it at expensive hours. But this is not the only capability that is brought by the battery. A battery is an energy unit that can respond in less than 1 second. It can respond in the positive or negative direction. And when we tell this to the ministers and the investors, it takes a little time for them to wrap their minds around this because they think that we have an established production potential from fossil fuels. So you can produce 1 gigawatts of energy. But in this operation, we are focusing on the idea of producing less than 1 gigawatt in real time. But now we have this opportunity to give and take energy to the grid in less than 1 second in the positive and negative direction. That means frequency control. So having equal amount of energy production and consumption instantly will be potential in a efficient way, because if you have more production and less consumption, there is a shift of frequency which will create an impact, and you need to respond to that. And if you can respond fast, you can prevent it before it gets too big, and you can send away some burden, and you can use tertiary systems. But now we can use batteries to ensure fast frequency control. Of course, to do that, you need to have the right battery system, the right inverter system, and the right software. because fast frequency control depends on seconds. So if you respond too late, your response will have negative consequences. So considering all this, high advanced systems will be able to participate in high contribution platforms. And we have a reactive system, and that creates problems in our connection to European grids. And at TEIAŞ, they did this study, and they saw that as of 2026, all inventors that will be established will be able to give reactions at 100% and ensure frequency control. And they will be able to pave the way for unidirectional applications of the future. Maybe you are a consuming facility, and cutting down your consumption will be a service to the grid. Or if you are a manufacturing facility, and if you push up your manufacturing as a block, that will be a source of income. And this also means that 10% or 20% of the batteries can be paid for capacity. So when you add all that up, the budgets of coal power plants or natural gas power plants will be moved to these facilities, because in abroad applications we see that early response and fast response will reduce the need for such services. And the vision of TEIAŞ, the ministry, and the Energy Market Regulatory Authority, we see that faster markets will emerge. And with the inclusion of the battery systems, the new opportunities and new revenue models will be brought by the battery storage systems. And this will make the work of TEIAŞ much easier. If you have any questions, I would like to address them. I would like to ask a question to Elif. You know, the permit process is something we discuss. We have stock-related problems. And these stock processes are moving slow due to the long permit procedures. I remember in the UK market, maybe some of you know that, there is this concept of the commissary of the electricity grid. The mandate of this person is to speed up the operation of the energy regulatory authority of that country. Can we have a similar system in the legislative regulatory processes? What are the challenges in our procedures? And how can we overcome these problems? Doğa and Hakan already responded to that. During the feasibility and implementation of these projects, there may be different models for application that we can use, but to implement these projects, we first need to complete the permit procedure. And there is a multi-stage process here. After you get license from the EPDK, the Energy Regulation Authority, you need to assess the land and the property, and it goes all the way to the development, and every stage has its own priorities. Most of these licenses are based on farmlands and treasury lands, and there may be differences in these procedures, and the institutions base their approaches on their own legislation. So having a more central, coordinated approach will speed up these procedures. Last year, a bill was proposed to the parliament. This bill aims to speed up the permit procedure, and all that procedure will be managed by the ministry. If that is implemented, these projects may be implemented more quickly, and the challenges of the investors may be overcome more easily, because we also have to get preliminary licenses and we face many challenges, and those often postpone the implementation of these projects. But with this acceleration, I believe many power plants will become functional very soon. There is a lot to discuss, actually, but I don't want to take more of your time. But there is something that was covered during the other sessions as well. What do you think about having enough capacity, storage capacity in Turkey that will cover all the production? How long do you think it will take for us to achieve that? Because the investors are looking for solutions to address that problem with minimum cost. Let me go first. Maybe the others can take the floor later. When we look at the legislation, the most important factor is having a more stable grid. The legislation on storage of wind and solar energy was published because these are irregular energy production facilities. You don't know when there will be sunshine, when there will be wind. So in terms of capacity, the progress was achieved only at 1-to-1 ratio. And this was done to ensure the de-energization of the grids from wind and solar energy. I think that was the main goal. Elif, I'll give it over to you. Actually, we talked about many things, but I would like to say that with these permit procedures, we need to improve the revenue side and facilitate the permit procedure so that these projects can be implemented more quickly. Maybe I can add this about these capacities. We have seen zero prices. When you look at the subtotal, these zero prices often occur during holidays or weekends. In reality, there is still some time till we see zero prices in other times as well. So there is a problem of imbalanced power. The more power we have, the easier it is to balance it. But boosting the energy at the existing power plants will cost less, because people tend to think that selling energy at the expensive hours may be more costly, but you mainly invest on inverters and batteries. So the main issue here is power, and the Ministry of Energy has to establish this power infrastructure. And I think in 3 or 4 years, with the increase in the number of the solar power plants, the daytime prices will be closer to zero, and then we will have a way to go to minus prices, because minus prices mean more revenues for batteries and more investment opportunities for other players in this area. So maybe in a few years, after these power plants use their existing revenue models, will increase their power. So I think it will be a good infrastructure investment. Thank you very much. Distinguished participants, this is all we have to say. We don't have a lot of time left, but if you have any questions, we can address them. I think everything was quite clear. Thank you very much for tuning in, and I would like to thank our panelists as well. Sorry, there is a question, I guess. Could you help with the microphone, please? Hello. This is a general question. We can, of course, we can discuss the revenue models, but we are talking about YEKDEM in electricity prices. We can use arbitrage, but there is a cost of using bidirectional system. And if we if we get from the power plant, it is $6 per megawatts. If we get from distribution, the cost will be lower. So, what kind of an economic source of income could we have with arbitrage? Because you need to operate when there is no production. If you have a power plant with 10 megawatts of capacity, but if you can get only 6 from the solar power, you need to top that up with the grid energy. So if the gap is $40, you need to use that. So your revenue will go down by $20. So do you think the cost for using bidirectional system can be eliminated? Well, we are working on the cost of bidirectional distribution, and it doesn't make any sense. Because globally, if you are storing energy, they don't charge any bidirectional service use, because somehow you are servicing the grid. So there is some work being done on that, and the ministry is positive about it. But for example, your power plant has a capacity of 100 megawatts. And you enter 90 megawatts because of the lost days, and you are short by 10 megawatts. There will be a gap in the transformer, and you will still be able to do some operation in the market. You can store some of it, and you can buy or sell energy for the remaining portion, because there are two different meters, the YEKDEM meter and the market meter. The energy, you can store some of the energy that you produce on the YEKDEM meter, and you can sell the remaining amount using the market meter. Well, you are storing energy that you produce, and you can sell some of it to the grid or just store it. But you said, I think you said 90 megawatts. When producing 90 megawatts, you have to store all of it and get 10 from the grid. No, you can store some of that. If you are producing 90 megawatts and you have a remaining capacity of 10 megawatts, you can use it for trading of energy. You can get that from the grid, or you can sell it. You can sell the energy from the storage. So you're talking about two different transformers. Yes, transformers are separate and the meters are separate. There are two different meters. There's the main meter and a second meter operated by a peage. So that's how you can do it. In the triage regulation, there was only one meter. No, there is another meter on the storage. There is 1 meter points. One goes to the grid, the other is at the outlet of the inverter. Since there is one transformer, no, there is not a single transformer. It's a drawing of the meters. So you don't need to consider the number of transformers. What matters is having a meter at the outlet. So your meter is the ekdem meter. So there will be two short sites. It has nothing to do with the short. But the step-up transformer measures it where? You don't know where you produce the energy. It doesn't matter where you produce the energy. What matters is what goes through the meter. The APH pays you what goes through the meter. So the inlet and the outlet to the grid is via one line. Yes, it's via one line, but that one line can be used for two different operations. Consider a line of 400 kilowatts, and there are millions of users on that line, and they are being billed via different meters. Maybe we can discuss the details later. Thank you. I would like to thank the participants and the panelists very much. This is the end of this session.
sunumumuz için moderatörümüz Sayın Sacit Akbaş.
Volkan Savcı Öden, Erman Toprak, Önder Akar, Engin Oruç. Thank you. Hello, welcome. So, I want you to hear us easily because there's a noise on the right side, and then welcome all again. And today, maybe you had the possibility of participating to the sessions, and people spoke about the revenue models also in those sessions, but this is the real revenue model session. We have Mr. Volkan, Mr. Erman, Mr. Önder, Mr. Engin are together with us, and we would like to thank to all of them for their participation. And so I'm trying to be trying to follow those sessions from the beginning. But now let's speak what happened in the global area, because there's an energy transformation in the whole world, and it is in line with the climate change, and it is a must. And there are so many parameters going around, but we tell hydrogen, IoT, batteries, we see EVs, and there are so many parameters going around. But the World Energy Council made a determination in 2017, and there's a trilemma for this, and energy must be green and energy must be available and as you need. And so we need to solve this dilemma, because but until the batteries they come into practice, and in the so if you can give us some information on this, Mr. Volkan. So I want to continue like this. So there's the green transformation and there's the digital transformation going on all around the world. And in March in Europe, this solar production, with the explosion of the solar production, there has been a production over 20 terabytes. And if it is compared with the March of 2024, it's a 20% more. And in previous sessions, we mentioned that on the solar production and this intermittent production and increase in wind and solar creates this higher load on the in the grid, and the dark curve deepens, and the March did not have a seasonal peaks, and there is a production more 20 terawatt production, and it is expected to 30 terawatts. And this is just solar production, and this will create a great load. And negative, we see more negative price formation compared to last year. And there's in Europe there are around 10,000 hours of negative price formation, and it is the 50% of the total negative price of the last year. And this year, the studies tell us that for 10,000 hours, we will have by 25% of negative price formation in 2025. And it's about the management of the load and the grid, and this creates many problems. And the only thing to do that is to make investment to the energy storage systems. And how this is done in the world, China started for the first time this, and then another country is America. Then we have the UK, Germany, and Australia. And China has a storage of more than 700 gigawatts. And in 2024, global energy storage market is had a magnitude of 60 billions of dollars, and 2033 it will be more than 300 billions of US dollars. And in some studies, they are targeting net zero emission, and then all the investments must be done is $4 trillion, and the management of this thing is not. This happens with only with the energy storage systems. So this is the electrochemical energy storage systems. Why it is electrochemical? Because it has much more advanced technology, and within the total storage area, electrochemical and lithium iron batteries is now around 60%. If we look at it as the total storage systems, and how the revenue, and I will not speak about the revenue models into deep, but I will tell it roughly. It started with the power systems, then it converted into energy. This negative formation is needed for the energy. Arbitrage is important, and for the capacity, frequency control, and reactive power control, and the black start, they have a very high revenue potential. Another one is the carbon trade. Is one of the issues that we don't speak a lot, but the carbon trade. And then this was a brief introduction. If you have questions afterwards, we can give much more details. What you said is very important. If you compare the last March and this March, there is an increase by 20% for renewables, and this energy transformation is happening now. And if we give the Texas example, in LinkedIn they have new records each day, and so these are the months that solar radiation is not record high, but still this transformation is happening. Now we can go from global to Europe. What is the real application in Europe? We know that you have application in Spain and Italy. Mr. Erman, can you give us a little bit more information about that? Thank you. I want to speak about MNAC. MNAC works with LG, and so also we are developing projects abroad. And within this, I'm so happy to be here. First of all, thanks a lot for this opportunity. With NNAC, our policy was the same. So what we can do on this area in Spanish and Italian markets, because of our experiences, we have developed projects abroad, and in Spanish and Italian markets, we are developing projects. Italy and Spain, generally, especially after the pandemic, are two European countries that have increased their GDP more because of controlling in a positive way the migration policy, and also the optimum prices in battery prices, and now investments over there are feasible. And then these two countries now they have evaluated very well this situation, and they have continued with their investments. Also today I want to speak a little bit on the Italian markets, but in Italy, Spain is focused on solar more, but Italy has much more storage market. So if you look to YouTube and if you look to the conferences in 2020, you may see about other revenue models, but today people are speaking about uh, different revenue models based on batteries, and because of technological advances, how they can help to our ecosystem, and also from project development area, what we are doing, not only ENAC, but each project development company must give importance. So the site security is important for us until RTP, until the construction of the project, we go on. It is important to start from the beginning, especially for storage projects. We are adding an extra capacity to the grid, and this has influence on the revenue models. If they have most cost, then it, it means more cost for the investors. And if I make a comparison, we make minimizing the risk, and even after RTB, the investors they can get the real value in the project. So why storing in Italy? If you look to the magnitude of the market, the 1 gigawatts of storage market is not so big. It's the home and CNI markets in Italy is 4 gigawatts, but it is expected to grow because the system operators until 2030 they gave a flat rate of storage projects are 14 for Italy, and here the Italy is for 15 years for system operators. They have a fixed income for 15 years, and they have some advantages, and the investors and project developers they make them these investments much more bankable. So if you go to the bank, you understand if they would invest, they say yes. Because of this, there are some uncentralized structures. The Italian government takes into consideration centrally. Maybe we can discuss this. I don't want to spend so much time, but I want to speak about some challenges and some opportunities. First of all, in Italy, the north of Italy is full of hydropower plants, and it's a place where there's much energy, but generally investments are being done in the south, in Sicily, and so this creates some problems for the project site, and for solving this we have foreseen the problems. Then we have some problems with the grid connections, and in the south is not so strong, and you need to foresee the SDG costs very better, and this causes investors to have a better revenue model. And then there is also environmental effects. Maybe we are focusing more on financial models as annual return of the investment, but it is important to see what's happening in on the field. So we are solving the problems in the field, and we are offering solutions to the investors. So today, for example, if you ask to ChatGPT what are the 5 factors for investment development, it can tell you. But what we need to do is to respond to these questions, to these problems. So if we can create some fast mechanism in order to respond to these problems. And now, by saying all this, I'm now leaving the floor to my friend. Yes, we were in the storage fair in England in February, And the hot markets in Europe are Italy and Poland. Italy is a good example because it is similar to Turkey geographically for renewable energies, and at the same time, the north and south line is just like the west and east line of Turkey, and this storage grids incentives of these countries is somewhat similar to YEKTEM, to ours, and all this can be done in Europe and the world. They became so much important, and we are on the right track. So you said mentioned about 1 gigawatt, but gigawatts, but we gave a license for 33 gigawatts. But how all these projects will be put into life? What will be the feasibility of this? Let's get into details of this. Many companies are working on financial models, and they have three titles. One of them is CAPEX, another one is OPEX, and also interest expenses, and then the revenue. But the revenue side can be obtained from the renewable area, or the battery is the revenue source. If Mr. Ömer, can you respond to this question? It would be very okay. Can you hear me well? And today I'm representing two companies. So there are two different A plus energy is a and so we are trying to develop softwares in order to increase the revenue models, and in Europe we put them into operation, and also the revenue models in Turkey. I will talk about the expectations about the revenue models in Turkey. There are so many questions for that, so I will not answer about the lifespan of a battery because you need so much complicated calculations. But what are the factors? I'm going to try to tell them, and I will try to give you some figures. The revenue of a battery can change periodically. So if we speak about the electric market, we don't speak only about one market. So there were questions before. So there are some revenue items, revenue channels. What are they? One of them, the first one, a battery. Because of its technical capabilities, it is very important to have to use them inside services, and then they can be applied over there in the Turkish system. And the other one is the market. I'm talking about the spot market, before day market, within day market, and they have different dynamics. And the third one, if this battery is integrated with a renewable energy central, we can talk about the balancing over there. Of course, the integrated power plant also, there can be a balancing of all the portfolio. This can change from term to term. Something that can be good today, after 6 months, it cannot be like this. It has happened in Europe like this. For example, in Germany, the site services in the first years of the batteries is very important. Many batteries have been amortized within time, in a very short time, and then something. And in England also, like this: Baltic countries, Lithuania, Bulgaria, Romania, and so we see the similar trends. And what is that trend? Let's check it. First, they are talking all the time. This cliche. So something will change within this electricity market. The production cost, the marginal cost is close to zero, and when there's an intensive production, we expect that the electricity price will go down. When it is low and or when it is SFK or PFK capacity, when they will keep this capacity, it's not good to sell because the price is very low. And so in this case, this power plant will reflect all these costs to the site services if we think about the opportunity cost. And this will cause that the batteries at the first stage when they are in the site services, an important revenue item will be created by the site services at the first stage. Why this is for sure? Why do we change? Why do we think like this? Let's think about the solar power plant. So for the solar power plant, assigning its capacity to site services means that the unproduced site is placed to co-pilot. So there's a capacity and it is sent to TAH. If it is making a production from the sun, and then they can as the production goes up, then the integrated battery will be influenced by that. So if think that lowering the production is okay and reflecting this to the site services is okay, so this battery we are telling that this battery may have $50-$55, but this will not happen during the night. And for the wind, what will happen? And during the whole day, so there's the production by 30%. May change periodically, but after daytime, the wind is okay, and then the nighttime the solar power will be less expensive when there is wind in the nighttime. So secondary frequency control capacity creates an attraction in the market. Why? It's a simple mathematics. First, the SFK capacity need in the world is 1,100 megawatts, and PFK is 350 megawatts, and there is a difference by one third. If we look to the supply competition in the market, I don't want to get into much detail, but very briefly, in the SPK, we think much more attractiveness in the for the batteries. There will be more revenue over there. But for the arbitrage, as it mentioned in the previous session, in order to have an arbitrage here, there must be higher price differences, and this will be much more meaningful that when there is more negative prices. And today, the batteries that we are supplying the software, so this about 120 euros, but it is not possible in Turkey to make money of 120 euros. One of our friends mentioned that is about $20, but because of the dynamics of the daytime market, there can be more itinerations, and you can get more revenue with more itinerations. So you need to optimize altogether, and periodically at the first stage PFK is 350 megawatts. The batteries, when we have a 500, 600 megawatts of capacity, will be enough for that. But after that, there will be the SFQ stage, and after that competition, we were talking about a revenue multi-market optimization revenue model that we are talking about in Europe. But today, since we are in the beginning of this, right now, if we can answer briefly to this question, sorry for being so long. The side effects, the side services are attractive in the beginning. Also in the feasibility models, we see that the batteries that are made first, they will be much more advantageous, and within time they will have much more complex operational optimization. They will be in other channels. And for Turkey, thanks Mr. Öner, especially to have a wider pool in the secondary is must be much more wider. The frequency control is very important, and we are doing that. Yes, they are doing smart pass. We can announce it to the investors, and the primary pool is very small. It can be filled very fast, but there is also the secondary one with the lower margins, but this must be taken into also into consideration. We spoke about the figures. You gave us very important data. Now, Mr. Engin, so can you give us more information? And I think you have a presentation. Now you can. I will go there and start my presentation.
Merhaba, hoş geldin.
Hello, welcome. My name is Engin Oruç. I work at Pomega. I'm the engineering manager. We already did a feasibility tour, and we don't have the secondary frequency control here, but you can see how you can use the primary frequency control at an early stage to make a profit. I will first share project information, what we design, and the prices, the technical parameters, and the feasibility results. Here we have a 50 megawatt solar energy system and a 155 megawatt wind energy system, and with that a battery energy storage system of 36 megawatt hours. You see the manufacturing capacity. These are the data extracted from a real situation, and we work with Sancton department at a major organization, so they can produce a simulation of your project on hourly basis. Because when you just look at the annual basis, you may be mistaken. So you need to look at periods and days, because and hours, because even throughout the day, data may vary. This is we estimated that the operation will continue for 15 years, and we have the average prices for weeks and months. These are the primary frequency control prices because we believe they will go down in the future. The average price is 7.2 US dollars and MC is 85 US dollars, MCP. On the right-hand side, there's a smaller chart showing what will happen to the prices in the future. These are the technical parameters for energy storage, round-trip efficiency. The round-trip efficiency is 89%, and lifetime cycle is 6,000 cycles, and end of lifetime is 70% of capacity, and megawatts investment cost per megawatt is 23,000 US dollars, and yearly O&M cost is 850 US dollars per megawatt hours. And the simulation looks at these hours and makes an estimate for the future. The capacity for frequency control, the capacity for arbitrage. You will see the arbitrage here, but we may not call it arbitrage actually. It's called peak shaving actually. You may not call it peak shaving. It is the operation that we do to make a more efficient use of renewable energy. In year one, you see PFC is unbelievably high. And on the right-hand side, you see in the chart that yearly discounted cumulative revenue is given. How much from frequency control, how much from arbitrage, and how much from storage of surplus energy. So the revenue from optimization of renewable energy or curtailment avoidance, because we cannot sell too much energy. You see in early years, PFC is too high, but very low in the subsequent years. And 49% of the total revenue comes from primary frequency control. Here we don't have the secondary frequency control, but there is a potential that we may replace primary with secondary frequency control. So in year 4 or 5, you may have a very high input from secondary frequency control, and recovery of the system will be 3.6 years. So your system will be paid back in 3.6 years. So this is a very profitable business. But as I said earlier, the systems are not quite clear. At least in Turkey, we have the primary frequency control. But there are two preconditions. You need to have more than 30 megawatts, and you need to be connected to the transmission system. Otherwise, you cannot participate in this. For secondary frequency control, you need to have 30 megawatts and connection to transmission system. And there is the fast frequency control system, but we don't know the conditions. The TEAŞ has not clarified the conditions. But it may maybe not during the noon hours, but during other times, this service will be covering most of the energy need. And arbitrage is not sensible, because when you use 6,000 cycles, you will have a cost of $30,000. Add to that the system use cost, and then it's not reasonable to do this. And renewable energy optimization, you need to do this by design. If you have the proper area, you can have a good revenue from that as well. And imbalance cost, this does not cause you bleed money, but it may prevent you from bleeding money, particularly for wind. It's more difficult to make estimates, and there may be penalties like 3%. So to avoid these penalties, you can use imbalance costs. And for the future, you can have spare capacity services. They are doing it in the UK now. In the UK, the US, in Russia, they are doing it for 1 year or 2 years. You get a reserve capacity and you pay a monthly fee and you feed into the system, and there is an instant request. And particularly during holiday areas, when you have too many EVs during summertime, there will be a huge burden on the grid. Maybe TEAŞ can create an additional source of revenue using this. And carbon emission and trading platform can be created. I think this will happen in 2 or 3 years. So with the primary frequency control, if you invest in this, it will be profitable. But how sustainable is it? The conditions have to be clarified. But currently, it looks like something that is doable. Thank you very much, Engin. You touched upon so many points that we feel like just going and doing it tomorrow. And this is feasible with a very high capex because since you're a supplier, it makes sense to give high prices. But even the existing revenue models and the methods and the investments show that battery is not just a burden, but also a source of revenue. You gave the example of PPK, but Önder said SFKs is also a source of revenue. I would like to say something about arbitrage. There may be some misunderstanding about it. The preliminary licenses in Turkey are storage integrated renewable energy systems. If we do not have these storage systems, we cannot use those power plants. So it's mandatory to have these storage systems. So you mentioned the price per cycle. That's very important to calculate it. And we need to add the distribution cost. And it's enough to cover the arbitrage with that. Then you can add the battery installation cost, but you cannot expect arbitrage to cover that because you will be installing the battery anyway. So when because to operate that power in plant, you have to establish that battery anyway. So you do not need to have an arbitrage that will create that will cover the gap in your budget. And it has been a very good session, and we have a packed hall, and I think there may be some questions. So any questions from the audience? So everything has been very clear, so no questions. Erdem just says thumbs up. Okay, then thank you for your attention. And the panelists are İlker Aydın, Rıfat Anıl, and Evren Evcit.
Çok teşekkürler.
Thank you very much.
Öncelikle hepiniz hoş geldiniz.
First of all, welcome.
Çok güzel bir Solarex Enerji fuarındayız.
We are at a great Solarex Energy exhibition once again. Since we're talking about storage, I was in Dubai last year. There was an energy exhibition, and everyone was talking about storage, how to store and manage storage of energy. This is the talk of the town these days. So
Misafirlerimizi tanıştıracağım. İlker Aydın balkondan, Rıfat Anılay'dan smart'tan, Çağatay Şahin
But Anın,
hoş geldiniz.
Zest Energy are the companies of our panelists. We have limited time. I would like to start with İlker Bey. We are talking about storage and technologies. And there is the LFE technology, the lithium iron technologies these days, and there are other technologies. So could you explain what are the differences between these technologies and which investment would be smarter for investors? Thank you. For about 15 years, I have been working on energy storage systems. And therefore, I have been involved in various activities about ISS with various energy operators. And the lithium iron phosphate batteries are the most common method of energy storage these days. But of course, it gives us some advantages in terms of chemistry. However, China has the potential to create a big market for this technology because the Chinese government has started creating this market domestically, and many technologies are patented by Chinese companies. So LFT has become more preferable due to its cost efficiency and long service life. Unless another type of chemistry is found, this is not set to change. But there are other chemistries like sodium ion. Some of the companies producing LFD are also working about LFI are also working with sodium ion, and the cost may be 30% less than LFI. But since it has not been patented, it's not widely available. I think in the future, LFI and sodium ion will be the two most dominant technologies. Vanadium redoxy is another technology. I studied it about 10 years ago at Istanbul University. We created a prototype and some master students wrote dissertations about it. It has a high cycle life, but it's just a marketing technique. It has 4 different ions. This is where the advantage comes from. The storages on 2 sides can charge and discharge in turns. But the life of the other parameters is also important. There is the proton exchanger, fuel cell, pumps, fluids with high acidity like sulfuric acid. So it has a lot of complications. So the lifetime of the other components is also important. In practice, you cannot achieve 15 years. And these cells have to be connected in parallel. And for the same megawatt hour, you need to have a bigger facilities, so it has a footprint issue as well. And operating and the operation is not as easy as operating lithium phosphate iron batteries. And sodium, sulfur, and other semi-flow battery chemistries that Japanese companies are working on. But due to the supply chain and the established systems, the lithium iron phosphate and sodium ion technologies are more dominant in the BSS technologies. Thank you very much. Now, these storage systems, like the solar power plants, have to be implemented with government incentives. These incentives include incentives on auxiliary services. I would like to ask Onur Bey, for management of storage systems, what kind of incentives are offered by TEİAŞ, and how do we manage these auxiliary services? Well, in the operation of a battery, the main goal is to balance the renewables. To achieve this balance, as the amount of renewables in the energy mix goes up, the need for auxiliary services goes up as well. We have PFK, SPK, and YALIA instructions. Well, we cannot call them exactly incentives because storage by its own has a significant advantage. They don't have any manufacturing costs. So the other PFK and they have a significant advantage as compared to PFK and SPK participants. And in the previous session, Önder summarized this already, particularly as compared to unit costs of SPK, you can offer SFK at very affordable costs. So they are like competitors. And what's happening in Europe? They have AFRR and MFRR. MFRR is the YALIA instructions and AFFRR is the PFK. In terms of auxiliary services, European countries have become aware of the potential and they have launched some initiatives. And many European countries are thus supplying these components from a single source. For AFRR, they have the Picasso. For AFRR, they have the Murray initiative. And because of that, all of these products can be supplied via a single point. Some countries have started implementing it. Others are set to implement it. And in the future, every country has a timeline as to when they will join this initiative. Particularly Germany and other countries are supplying these products, and in time other European countries will join these systems and they will also participate in these auxiliary services. And sometimes we see the minus prices in Europe, like we see peak prices like 500 euros per megawatts. So storage is important. Currently, a capacity allocation has been made for 34,000 megawatts. Some investors want to have storage systems for their own manufacturing facilities, but there is the problem of capacity. And the ministry and the association have negotiated this issue to create storage systems for facilities. Can we do anything about them? Can we build these systems? Yes, according to the directive, you can have individual storage systems. Article 6 covers that. We haven't focused on that too much. Much of the attention has been on 34,000 megawatts. But individual storage facilities have this advantage. These industrial facilities, businesses, use these behind the meter storage systems that can be used without tapping into the grid. And these facilities can only be used for the internal consumption of the facility. And there are specific reasons why people do not pay attention to that. Maybe in the future, when the grid is not very stable and when there are power outages, the companies that have their own individual storage systems may see some advantage, and only then people may start paying attention to these facilities. Or maybe in the future, people can have rooftop PVs or on their own property for internal use. And instead of selling it to the grid, they can store it in their own batteries and use it for their own consumption. Because distribution costs are going up and getting power from the grid or giving energy to the grid may seem costly. Maybe on the storage side, if the costs go down, the number of these individual facilities may go up. So thank you. We hope that without hitting into the problem of capacity, everyone can build these storage systems for rooftop PV systems at their own facilities. We have talked about EV batteries and battery health has to be 85%. That is the restriction that is currently applicable. So why battery health is important for these storage systems or different battery systems? Why battery health is important to avoid Turkey becoming, to prevent Turkey from becoming a landfill of batteries. When we look at the battery health, we look at the loss in the capacity of a battery. As a standard, when the battery health goes down by 30%, it can no longer be used. In BSS systems with phosphate infrastructure, particularly there is a market regulation. They can only be used for 1BC levels, and that causes heating in the battery, and that heat has to be taken out of the battery. Otherwise, the battery will be damaged in time. To do that, thermal management and power management have to be done very carefully. This is done by thermal management systems and battery management systems, the BMSs. Well, becoming a landfill of batteries, we need to think about it because Turkey is seriously maybe 5 years after establishing BSS systems, maybe 5 megawatt hours or 10 megawatt hours. When they lose their capacity, two things may happen. They may continue to use 5 megawatt hours as if it is 3 megawatt hours, or you can give a second life to these batteries via some companies. These companies will emerge. Germany and China has these companies, and I think we will have them as well. These batteries can be used for other applications that require less energy. They can be analyzed, and the batteries with similar parameters and age can be brought together and can be used for backup applications, for example. And this will happen. This will help us get several usages out of a single item. They are discussing this in the context of EV, but the chemistry used in the EVs is NMC, so the cycle life is not very long. So it doesn't look like these second life batteries can be used everywhere because getting the models out of this EV battery and get components out of these batteries and use them for something else can be dangerous. This second life practice may be available here as well in about 5 years, and maybe this will reduce the amount of waste batteries. Well, the thing about these batteries is fast charging and discharging will shorten the service life of a battery. So charging the batteries at lower rate and keeping the temperature at around 25 Celsius degrees will help you get the maximum use out of the battery. And the systems should be designed according to these requirements. As long as you do that, those 3,000, 5,000, 10,000 cycles can be easily achieved, and LFD will give you ease of mind in terms of return of investment. Thank you very much. Now, Gökhan, storage is now being considered in the context of wind and solar energy, but we also have the arbitrage, buying electricity at the cheapest hour and selling it at the expensive hours. That's another way of making money. They are doing it in Europe. And there's a tendency in Turkey as well. We have individual storage systems. Can Turkey have an investment plan like that? Can it be a tool for participating in the market?
A short answer, it's not possible. Arbitrage means that you buy it at low price and sell it at high price. And in Turkey, so when we consider the cost of the storage, there is no possibility for that in Turkey. And the first reason for that is the price ceiling application and base price application. And even since it is not even $100 the ceiling, it is not possible to make money. And you are not able to make money at all. And if we summarize the process in the Europe market, everything starts with a site service, and so you are estimating this market price estimation, and you make an estimation, and there's an opportunity cost, and you make your offers, and as a result of those offers, you will understand how you're going to reserve your initial capacities. Then afterwards you make your estimations for the pre-day market, and while making offer over there, you need to have a feasible program, and intraday market then starts. So pre-day or site services prices are already known, but intraday market means that that market is open for a long time. After 3 o'clock, it starts in Turkey, and then 3:15, 29, it's open around 33 hours. So here you can look for new opportunities, and your arbitrage within the intraday arbitrage is continuous, and you can buy and sell directly when there's an opportunity. Maybe intraday market there can be arbitrage opportunities, because the financial arbitrage can be seen in Europe markets. And thanks to the price difference in here, you can make an extra revenue. And this financial arbitrage is based on the three times of the charge price of the battery. When there is too much volatility, for example, in Germany, it means 1 to 10. So if you feed 1 unit of energy, it can be 10 units within the day. There's a fluctuation, just like in Germany. And of course, it's not possible for one operator to manage all of them. So during the day market, you can make new offers. And thanks to digitization and autonomous management, it is very possible this situation. The whole storage can be managed in this way. And as a complementary to this, after each trade, the battery charging and discharge program is sent to the battery, and the battery, based on the load in the market, must be charged. So if you have autonomous system for managing this, so you can manage all this without touching anything. Then I can conclude my words like this. Thanks a lot. So Mr. Ilkan mentioned a little bit about the batteries, about the 05 batteries. 05 batteries are sold so much, but at the end of the day, people are preferring the one type. But which one should we decide? 05 or or one? Mr. Dikan mentioned before when what is his rating. So he mentioned the difficulties of the one batteries when the batteries are heated. So in our country, when we get these licenses, we thought as the C rate 1. Maybe that purpose has deviated over there. Maybe we thought to get a license and then we thought afterwards the storage and C rate accepted all the time as 1. But the regulation all the time mentioned that output of the storage must be minimum like this. So let's think about the 10 megawatts as the PCS and the exit power and the battery power can be 10 megawatt hour according to regulation, and this is the case where the C rate is 1, and if it is still this PCS power is 10 megawatts and storage power goes to 20 megawatt hours and the C rate becomes 5.5. As I give 1 unit of energy to the grid, so should I supply 10 or 20 megawatts to the grid for 1 hour or 2 hours? It shows us the 0.5 or 1 C rate. My PCS power of storage or PCS power, then I feed this for 1 hour, and so charging and discharging situation for 1 hour. And if there's a charge of 1 hour, we don't we treat badly to batteries and we lower the cycle lifetime. And the regulation tell us that for the first 5 years, my I have to keep my storage at 5%, and at the end of the fifth year, I have to ensure the 80% of capacity. And when the C rate is 1, it is difficult to have this kind of capacity. Maybe there can be an addition to the battery side to this in this power plant. So we can explain these C rates of 0, 5, and 1 like this. And solar energy, wind energy, all these powers are here, are taken as 101. If 10 megawatts solar energy and AC energy taken as equal, and 10 megawatts are accepted as the battery power. But in the regulation, they say your DC power, your mechanical power, can be done as wide as the power plant. But the applicants, they did not take in consideration this, and they did not also consider for the storage. And this can create a challenge in the future because of the heating up and the lifespan of the batteries, and there can be losses. Thanks a lot. And maybe we can add this so people, for companies that want to sell these products, or there's a difficulty, the C rate when is one, because the C rate, we don't consider it so much one. We see 0.25 Cs. This enables much more stable operation of the system. But when the C rate is one, it's difficult for everyone. I agree with that, yes. We mentioned about the battery and in the power plants with storage. There's the storage and battery management, and the wind plant and solar plant automation system, SCADA system integration, and the phase system integration is very important. I want to leave the floor to Mr. İlker, please. So the battery energy storage system, as a matter of fact, if we think as the electric grid as a circuit, this acts as a capacitor. So when this will be operated and when it will not be operated, somebody must give a command. And if there's a problem with the batteries, we need to determine this, and this must be integrated with the power systems. And so another software managing the system, telling that so get for the operation must be in line with the power system and master BMS and slave BMS. They are communicating intensively, and for based on this, the power adjustments and turning on and off applications are done. And there are some standard protocols interface for communication between all the systems, but there's not so much standard between the protocols, especially the communication protocols inside the system. Each manufacturer can use different things. For example, there are some special CAN bus protocols or Modbus protocols can be used, or TCP IP protocols, Ethernet or wireless protocols can be used. But in order to enable the system to do all of this, a master BMS or energy management ESS management system is present. Upper order, they speak with the master BMS and PSS, and it speaks with the cooling systems or fire execution systems can be communicated, and each one of them has different protocols. So the system must be multi-protocol and must be multi-interface. There's nothing magic so that can operate directly. The system integration, if you do something new, it is not something ready. You need R&D work, and you need an engineering service for that. The whole systems are connected to generator systems or to the grid and takes the energy or gives the energy as is done in the arbitrage or smart grid and SCADA systems must be communicated, and they also have their own protocols, and there's the data integration for that. Also in Turkey, there's not so many direct standards for that, and there is also you need integration work to be done. So the software and hardware companies must be present for doing all this, because not each equipment talks to each other. So different cans may not speak with each other, So one or the other part must be corrected. So we don't. It is not possible to connect anything that you buy from China with other products that you buy from China. So there must be a compliance work. After ensuring all of this, the system can be stable and it can operate it based on your commands and without creating any problems. And regarding this, in Turkey, at our friends at EDEDER Association, we are working on different parts of that, and we have an accumulation of know-how, and we will have safer systems that will talk to each other. Thanks a lot. So I want to add something. I'm going to give an example regarding the integration. I think it has been 4 years or even 4.5 years with the battery that we bought from China, and we want to integrate it with the inverter. They were not talking with each other before, so we bought an inverter, as a matter of fact, from China, and we wanted to integrate it to a Turkish battery, and the inverter must know the tension level of the battery. If not, the inverter can require more energy and may cause the explosion of the battery. Our battery did not explode, but we have made some tests and experiences regarding that. I wanted something more. Today we were speaking with one friend, and for example, Canvas is a language, but there are different dialects. So it can be, and the protocol conversion is needed. So we bought from A the inverter and from B the CAM system, and they asked if we can do something to convert. We can do a software and interfaces, but all this work, this is done in this small cart. What would be the price? And the price, they say that it can be $100, but no, they cannot talk to each other. So nobody wants to pay for that. They just want to pay $100, $1,000, etc. The engineers, they don't produce because there's only one person to buy. It's just like it's a customized work, and it's a tailoring system. So if you can do it, you can take it from Chinese, from whose you buy. But if not, they cannot communicate. So you can say it's a CAN system, but they cannot do it. They cannot communicate. I want to tell to Mr. Anil. So in the final 3 or 4 years, we are talking about the storage costs, and this causes the increase of the costs of the main power plant, the local contribution, the power conversion systems. There are some guarantees for them, but the contributions in Turkey are enough for this kind of investments. What is the situation regarding the contributions given? We need to speak firstly about the abroad countries and their incentive policies, and Turkish uh, RES power plants with storage in Turkey. There's a very good incentive, one of the best in the world, because without any capacity restriction, you can install or solar power plant or wind power plant without any limitation for storage, but already your power plant, you have a guarantee for that. But why do you need to have a storage in this case? Because you have a guarantee for purchasing, but there are other methods for guaranteeing your revenue besides the guarantees for buying. For example, for the battery management system, so you don't need a battery trade system. Even for us, there shouldn't be this kind of trade system because your energy management system at the end of the day, your battery SCADA is responsible of the general operation of your battery, and the wind or solar power plant is being operated. This is the local SCADA. But so this structure, so APH or other international operators can be integrated into this, and to it is not logic to make the trade of that. The reason are two. One of them is the portfolio management, because in the electricity market, not only your local commerce can be done, but you can do all the trade in an integrated manner. For example, with your gas storage in Istanbul must be able to do the trade of your power plant in Şanlıurfa. But what will be the scope of it? How are you going to monitor these two plants? These are two different responsibilities. So this management thing must be taken out of the trade thing. And secondly, this should not be done compulsorily by the investor. The investor,
Pardon, bir şey sorabilir miyim?
so your revenue is fixed because of those organization, and when you go to EMS, so a trade, you don't need to buy a trades management system, and with these two methods, take them and incentives or your PPA agreements, so your there are some methods for guaranteeing your revenues. This can be mentioned like this. Thanks a lot. Our time is up. So, but there's the final question for Mr. Çağatay. Of course, we have some projects that are approved. So, but I want you to speak about the acceptance processes. So, what all the acceptance systems are clear in today's legislation? Will the ministry be accepting these projects directly? And what are the conditions? If our time is up, I can tell you the most important thing. So just 3 months ago, this has been applied to EMS, BMS articles have been added. The most important thing, after when the acceptance is done, so I can continue based on the examples with the 10 megawatts of of uh, of a system. We have a charging and discharging system, and we want to discharge for of 10 megawatts. And if you can send 10 megawatts to the grid, your storage capacity also is deemed to be 10 megawatts. It is if you have applied like this. But if you are able to send an energy of 9 megawatts to the system for 1 hour, there's a tolerance of 10%, but if it is below of 9 megawatt per hour, the acceptance can be cancelled. So what you need to take into consideration mostly for the acceptance is this one, and this 10% tolerance must be taken a little bit into consideration. But in the first 5 years, if by 85% storage power capacity must be sent to the grid, and for this reason, it would be good to select the storage capacity a little bit higher. This is just a discharge, but there's also charging tests or for the acceptance time. So, which will the time interval? There will be a mobile storage car or etc. This must be taken into consideration. The projects are newly approved. There are some preliminary approval, and so we are so curious what will happen during this first initial acceptance steps, and so much data must be transferred. Also, the storage, when the storage is added, the cooling systems, the temperature levels, all of them must be able to be integrated to the system. All this data must be given, and these are tested at the acceptance point. These are the most important parts. Hopefully, we do an acceptance as soon as possible and we see it together. Thanks for your time, and our time is over. We will have another session afterwards. Thanks for listening to us. Thanks a lot for your presence.
The title of the session is Commercialized Battery Technologies. Can you hear me? I think it's working. Thank you very much, Mehmet Bey. Hello, everyone. Today, we will be talking about commercialized battery technologies. I would like to thank the organizers of this exhibition and the solar technologies. And I would like to thank the EDEDER, the Energy Storage Association, and its chairman, Mehmet Bey, for supporting this cause. My name is Kadem Usta. I have been working in the battery industry for 18 years. In the last 2 years, I have been the president of the Association of Battery Manufacturers. We have a panel of experts here. Let's get to know them and start with our session. Hello. We would like to thank you for staying until this time to listen to us. I have been working in this sector for 15 years. Actually, we first started working with the non-chargeable batteries. Then the industries led us to work with the rechargeable batteries and bigger battery packs. I would like to share my experience with you as far as I can. I am an expert of solar energy systems. Currently, I have a company that is a supplier of energy systems. Let's talk about battery technologies, what kind of batteries we have and what kind of applications do we have. Let's first hear from Duygu Hanım. Which batteries are more popular in solar technologies? The success of solar technology is due to the chemical that we use in the battery. You can use many chemicals, but in today's conditions, considering the efficiency, lithium-based batteries are more prominent. Why? Because of high energy density. In a small area, they can fit in high volumes of energy. It has charging efficiency. Its internal thermal resistance is high, and also the costs. Its cost performance, efficiency, and the capacity of lithium batteries are better. But lithium batteries also have different segments. And among these segments, lithium iron phosphate is more popular as a storage system because their cycle life is 4,000 to 8,000. That is 30 years of sunshine, and they have long service life. This is why they are more popular. Lithium iron phosphate is more popular among all lithium-based battery systems. There are NMC batteries as well, but NMC batteries, due to high internal resistance, they are not preferred, and LTO batteries are more balanced, but they have a very good service life, but their cost performance is not very well. In summary, iron phosphate batteries are more preferred in solar technologies. They're efficient, and you can fit in higher volumes of energy in a smaller capacity. I think NMC is more used in automobile and in areas where you have high energy density and where you have shorter cycle times. Yes, you cannot hear me, I guess. Sodium ions. Where does sodium ions stand? I came back from China about 1 week ago. I stayed there for 3 weeks. I visited many manufacturers, cell manufacturers. Yes, they're promoting them. The sodium ion batteries are promoted, and we see them in the product lists. But there are very few. There are no products that have been actively tested and validated, and everyone is looking for something. And the manufacturers are promoting their own products and listing them in their portfolio. But you go to the facility, you don't see them. Even if they are manufacturing it, the NMC does not have a market yet. Maybe that's why we don't see them around. But so far, I have not seen them being used actively in a project, particularly in Turkey, because in Turkey we have a cost-sensitive market. We are fighting with costs in every project. This is why maybe they are not in the market. Maybe further in the future, they may come here as well. Thank you very much for the information about batteries. In these battery technologies, about the integration with solar systems, what kind of contribution do we have from batteries? How do we improve the efficiency of solar systems with batteries? Kemal Bey, please. Well, I can say this. Indeed, a full integration of solar system can be achieved only with battery systems, because solar systems are never baseload centers. They are time-dependent facilities, weather-dependent facilities. The manufacturing line is never a plateau, never follows a plateau. It reaches the peak point during noon hours. And in the morning and at the evening, the energy manufacturing is less. Well, we can ensure the integration with energy systems by this way. The first method is peak shaving. You can get the energy at the maximum level during peak hours, during the noon, and transfer that excessive amount to the other times of the day when the energy production is less. So you actually manufacture energy at noon, but through storage systems, you can have a flat line of manufacturing as if you're also manufacturing in the morning. Because as you know, you need to keep the daytime consumption and nighttime consumption under control. And the main problem with the solar system is integrating it into the grid. To do that, you need a storage system all around the world. It is mandatory to have a storage system to build a new solar power plant. And we see minus prices all over Europe. And to achieve that, at least a portion of that generated electricity should be stored and used during the morning and evening hours. Secondly, we can say this. Unbalanced energy generation may vary during cloudy weather, and the failure to predict that creates a problem with voltage and momentary losses in the energy supply systems can be brought to baseload level by using the storage systems. This is what we need, actually. Grid operators, just by using battery, currently cannot respond to the total need in the total demand in the market just using the solar systems. They need to use the traditional power plants, the wind power plants, and the solar power plants. In the future, we will have prosumers. And to achieve this distribution of energy, all solar power plants will be obliged to have a battery system, a storage system. Well, renewable energy, wind, and solar energy. Will we have base load with them, or how long will it take us to have that base load? Because that's an issue. We wouldn't have a foreign trade deficit if we didn't have to import energy, and we would achieve a very good level of welfare. Can we do that by using the battery technologies? Yes, that may happen, but the investment that you need to make would be colossal. As you know, we have the storage licenses being distributed. The total amount of storage capacity of 33 gigawatts, and the amount of investment you need to do is not measured in 3 years or 10 years. It will take even longer. So do you think we will achieve these objectives by 2030? I don't think we can at the current speed. I think it is about 80 gigawatts by 2030. While the same applies for wind energy, we can have a very good generation during windy weather. And the main problem of the investors is the fluctuations in the wind frequency. I think the wind investors are more willing to install these storage facilities. And we see many examples of that in Turkey. The first to invest in those systems were wind investors. They have pilot projects. I think there's a pilot project, but the acceptance is yet to come. I think the wind energy will be first to do that because we will be able to control voltages with these storage systems as well. And there is this thing we call arbitrage, which is popular in the UK. You can buy energy during high price, low price times and sell it during high price times. And you can only do that with battery systems. And you don't have to have a solar power plant to do that. You can just have a storage system and just buy and sell energy into that system as well. The total base load of our country is 20 gigawatts. It may vary at times, but we need to have 20 gigawatts at all times. We have some power from wind and solar energy. So to cover 20 gigawatts, the total capacity of wind and solar energy plants in our country has to be increased by 5 times. And then you have to add the storage systems to that, and then you can have a base load only based on the renewables. So the 33 gigawatt hours of batteries assigned by EPDK are installed, then we will have base load. Well, there is a huge investment. There are local domestic investments and investments abroad. There are rumors. Some people say they are not making these investments to support the base load, but to use the arbitrage system and the price shaming system to generate revenues. Well, one of the most important issues is the price, particularly in large-scale projects. What are the price levels? Sartaç Bey.
Milyonlarda yine eklenti yapabileceğiz bataryalar ama tam böyle Duygu Hanım söylediği gibi ticaretleşmemiş aşamada. Şimdi şebeke ölçekli projelerde biz Türkiye içi veya Türkiye dışı olarak segment etmemiz gerekiyor maalesef durumu. Çünkü Türkiye'deki regülasyondan kaynaklı olarak sizin kuracağınız tesisinizin gücüne karşılık bir saat içerisinde deşarj olabilecek bir batarya kurmanızı istiyor. Bataryanın kimyasını tarif etmiyor regülasyonlar. Dolayısıyla burada da mantığa baktığınızda aslında bir otonomi var. Otonomiye göre de 1P veya 1C dediğimiz bataryalarla ilerlememiz gerekiyor. Bunu ama şu şekilde de yapabiliyorsunuz. 10 megawatt saate karşılık 10 megawatt saatlik batarya değil de işte 10 megawatt deşarjda 20 megawatt saatlik batarya da yapıyorsunuz ama bunun hala önü açık olmadığından dolayı bunu işte yakın ülkelerde özellikle yatırımcı tarafındaysanız değerlendirebileceğiniz bir opsiyon olarak karşınıza çıkıyor.
So there are different equipment you can use it for medium voltage, and so an investor and holding, so thanks to pre-license, can make a 10 must be over 10 megawatt hour, because for the transformation purposes, and we have some solutions for that. with the new lithium iron phosphate batteries. Do you know how much tax is applied on a battery? I can say either there we have a 30% of tax. So when you import a battery from abroad, you need to pay 30% additional. We cannot hear you at all. We cannot understand you. So, so you mentioned, I think, about the taxes. I just understood the taxes. Maybe you don't hear me. You are. Can you hear as well? No, the audience can hear us, but we cannot hear each other. So I wanted to say that for lithium ion batteries, so we must pay a custom duty. Also, we need to calculate that taxes is roughly 30%, and 15 or 10 megawatt project in Turkey, you can similarly, you need to use a battery of 10 or 15 megawatts battery, and you need to work on the conversion rates. Our figures are variable here from based on manufacturers, but it's around $300,000, $230,000. But we have the battery and the software and the macro voltage split is also present. However, the same system 05C 15 megawatts delivery, 30 megawatt delivery. So if you wanted to discharge it for 2 hours, so it can be 140 and $1,000, $160,000. But you cannot use these systems in Turkey because the regulation is not okay. This is the prices that we can talk about in Turkey. But if you look into international basis, if you look on the gigawatt scale, in China, there has been a tender of 600 gigawatts, and the price that they got was $65,000 divided by megawatts, and 80% of the companies gave below $70,000, and this shows how the prices will change. This can be an indicator, but if we apply it into industrial area, our prices go up by 50%. If you have a hospital or a factory or a small storage system with the small PCS, so your prices per kilowatt per hour is per $400, and so $400,000, and so your investment, the feasibility of the investment is very important, is variable. I think I may be able to give you some perspective. I think it can be it can be acceptable, but if you cannot hear me well, you can listen the other hall. So in order to use the time very wisely, if I can take a very brief answer. So these commercialized batteries, where they are being so used intensively, can you list them in 5 or 6 items? They are generally being used in automotive sectors, and so and there are different types of usages. and there are different chemical issues, and there are variabilities between the NCR batteries. The first one is the automotive sector. The second one is the storage issue, and also over there, the iron phosphate chemistry is important. Then we have the consumer electronics, laptops, smartphones, and some consumer electronics, some portable units can be used. And so iron phosphate battery are being used over there with different technologies. So prismatic cells are being used, cylinder batteries are being used. There are different batteries that are being used. Now, I want to change the topic and I want to ask another question. In 2030, there's an estimation of 2 million of EV vehicles for Turkey, and this is approximately 14 terawatts energy consumption of yearly per Turkey. So the more than 5% and less than 10% of the whole electricity produced in Turkey will be used for EVs in 2030, and more than 5% of the whole electricity will be consumed in places which is undetermined before. It's a fluctuating situation. Is that manageable? So, the so what kind of grid regulation is needed for this? We have some cities even that are living this kind of problem, that there's a wavy situation where the transformers are not enough, and the number of EVs are increasing. For example, in Bodrum, the charging stations will have difficulties in certain times, and there has been some, for example, in the religious festivity time, there are thousands of cars going to Bodrum, and if you think that all of them are electric, so we will need the commercial storage systems. For this reason, in the future, in each EV charging station must have a storage station. So it can be 100 kilowatt per hour or 500 kilowatts hour. So it can be a big one. 50 megawatt, 100 megawatt per hour is spoken. But when we look to the whole country, especially in places where there is intensive demand, in each station there will be the need for the formation of a storage plant. It will be done based on the charging stations, 200 kilowatt per hours or more than that. But you will not be able to charge your EVs, electric vehicles, without this kind of storage systems, because there is no capacity. So we don't have transformer capacity for that, and this will be a big problem of the charging stations. So the fluctuation, so by regulating the production, also the fluctuation in the consumption must be also regulated also. So you need transformers over there for storage. So we have now little time, but we have a question for Mr. Uygu. The house systems, solar home systems, the what is the effect of the batteries for the payback time? So if they cover this kind of payoff, if they have the battery or not. I didn't understand the question. You hear me less, I think. So what is the payoff time with the battery systems? If the cost is covered, within time, in a better manner with the battery system. According to our studies that we did, the sale prices and the component prices, they have a 20 years of lifespan. I think that this 20 years of time will pay off your investment, according to me, but at home. But beyond paying off, the doing some technological work in line with that, even though it is doable, we are talking about the infrastructure, transformers, and we are talking about the legislation for solar power plants, and so we are talking about the self-consumption systems. There are some more legislation, but beyond those calculations, we need to have better infrastructure, and within our country, our investments with our country must be developed in this manner. We have to be less dependent to the foreign countries. But if the questions, these costs will be covered within 15 and 20 years. The electricity consumption, as you mentioned before, is a national issue that influences our foreign commerce deficit. So the solar power plant that are used at homes can be much more productive with batteries, and the need for the grid electricity is becoming very low. This can be explained very well because the initial investment cost is very high, and generally the user cannot determine very well what is his or her need. So they need to learn about this. Last year, I had an experience while I was in a fair in Germany. I have seen a solar system for home with batteries infrastructure, and they worked on different costs based on different countries. They told me that in Germany, while paying off in within 5 or 6 years, in Germany, in Turkey, this is longer, is more than 8 years, and the reason for that is the subvention issue lowers the costs, so the payoff time, amortization time gets longer, or payoff time is the right term, and it is not so attractive in this case if it is 8 or 10 years. It's a national issue, but if there's a contradiction in here, we can ask it to Mr. Kemal. So these house systems, especially in Europe, in Europe, it is the biggest market in Europe is Germany. As you know, it is in Turkey, so it's a 5 megawatt power plant or 10 megawatts solar system. It's the same. All the procedures are the same, and there are very heavy rules for the regulation, and you need to overcome all these steps in order to have this kind of home systems. But in Europe, the government supports you, and you can set up your systems in a very short period of time. And in Turkey, for example, you need the municipality approval and other approvals. So I think it can be done very easily. And so, for example, we wanted to install some batteries in our systems, but we needed to also take some permissions from the municipality, and so for ourselves we were not able to make a sample investment, but it was not possible because of the permissions taken, and how we can sell in this case. Can you hear us very well? Do you hear the voice of Mr. Satach? So we were talking about the permissions, how to take permissions. We have some advantages. The electricity prices here is still low, so our payoff time is longer, but this can be an advantage for the consumer. For a home consumer, the payoff time is longer. For the reason it is much more feasible for industry. So there's a relative situation in here. But the main difference is because of the purchase buying prices of the electricity. Because in Europe, in Eurasian area, we are using very low price electricity if we compare with Europe. So it's a very important thing for us. Thanks a lot. Now we have completed our time. We can have a quiz session if you have some questions, and we can take some questions, one or two questions. Okay, if there are no questions, thanks for your contribution. Sorry, there's a mix of the sounds because there are two conferences going on together. Even though we did not hear each other, we have tried to convey some information to you. Thanks for listening to us, and I wish you very energetic day and very happy days under the sun. Thank you.